Picture this, it's September 2022 and the USA Mega Millions jackpot is at $301 million. Now, imagine if you could create your own lottery app using crypto instead. That's right, in this video, we're gonna be making the lottery Dapp on the Solana blockchain. I'm gonna be showing you guys how to make your very own Solana smart contract using Anchor, which is just a framework of Rust. I'll walk you guys through step by step how you can buy tickets, create the lottery, and transfer that sweet soul to a very lucky winner. Next, I'll show you guys how to use your Phantom wallet and connect it to your app. And of course, we're gonna need an RPC node provider to connect us to the blockchain. And our friends at QuickNode are gonna hook us up. We'll also be using something called Solana Playground, which is the place to create your smart contract, build it, deploy it, and for my favorite part, test it so that you can understand how all of the functionality works. So if this excites you, make sure you drop a like in the video and let's get started with the demo. And like I just said, this is a amazing, exciting app for you guys. We're actually making a lottery. We're taking what we know about Solana and I'll walk you guys through how to make this cool app. But first, let me show you around, right? This is how it works, right? As you can see, we have Phantom Wallet. We have another button here that we can use as well. And I'll show you guys how to set that up. But to get started and log in and connect, we click Select Wallet. We're using Phantom, of course, and there we go. Boom. The way this works is we need to initialize what I'll call the master. So once we initialize that, Solana will ask us to approve. Click approve and bam. Saw that? We have nice toast notifications this time and we can see that this is lottery number 0. Well, that's the initial state. What's the pot? Nothing. Who's the recent winner? 0. Nothing. All right, so how do we make some more life, right? Well, let's make a lottery. Do you want to make the next Mega Millions jackpot? Well, we can do that with Solana here. So let's click create lottery and let's hit approve and bam, now we're talking, right? So a lottery was created as you can see, and now we're in lottery number 1, right? The cool part about this is we can purchase a ticket, and every ticket that we purchase is gonna cost you 5 SOL. It's pretty steep, right? But luckily for me, I have 13 SOL right now. Let's go ahead and enter. Let's hit approve. Notice how it says -5. I bought a ticket and we can see that I lost some SOL. I have 8 now, right? So let's make this interesting, right? So let's use a different wallet. Let's say someone else logs into the very same app, right? And let's go wallet number 4. This guy's pretty rich too. He says 13. And notice a couple of things. I switched to my CV wallet, but now there's no pick winner button, right? Because the cool part about this, it's secure. The only one who can pick a winner is the one who created the lottery, and this guy didn't create it, so he can't decide who's the winner, right? So let's enter this guy in and let's hit approve. So there's a 50-50 chance, right? You want to make it even more spicy, right? Let's add to the pot. All right, let's add to the tally. All right, let's see wallet number 2. Does he have any SOL? He has 7. This is the poorest wallet I have. All right, he's gonna enter in. He's gonna hit approve, and bam, pot's now 15. All right, so 1 out of 3 chance. Let's go to wallet number 1. Right. Let's be a little bit unfair and let's make it so I have 2 entries. So let's see how many total tickets, right? So if there's 20, there's 4 tickets. 2 of them are owned by me. 1 of them is owned by wallet number 4. Let's say it's you guys. You guys are wallet number 4. And we have wallet number 2, right? So what we can do, since I made this lottery, let's pick a winner, shall we? So let's say pick winner. And let's hit approve. And the winner is 4A. What the hell? So that means I didn't win. I can't claim that money or else we'll get an error, right? I think wallet number 2, the poorest wallet out there, wins the prize. So this guy, he has 2. He spent his life savings on his ticket. So if I click claim prize, he gets 20 SOL. All right, so approve. Boom. Claim the prize. Those buttons are gone and you can see there's history. And you can see who won, right? So this is an amazing app. There's a lot that goes into it. I show you guys how to do something that's not really possible in Solana, right? You can't generate a random winner. There's something called pseudo randomness that I'll show you. That's possible. So look at this. Wallet 2 is now the richest man out of all my wallets. He has 22 SOL, and that's the demo. So are you excited to build this app? If you guys are excited, drop a like right now. Leave a comment saying I'm ready, Lance, so I know that you're watching. And if you want more videos like this, also let me know. So without further ado, let's get to the tutorial. All we have to do to get started is open up your terminal, go into the folder that you want to put this file in, and type npx clever programmer at latest. Once you do that, hit enter and watch the magic happen. You're going to see our CLI tool load up. It's going to ask you to put your email address. I'll put in mine, lance@cleverprogrammer.com. Bam, your name, Lance, and select the project that you want to load up. You guys don't have to write a lick of code to make sure you have the same files that I do. Right? We've done so many projects this past month. Right now, we're like doing the Solana lottery app, as you guys know. So let's hit enter. Right? And as it loads up, I mentioned before that we're going to need an RPC node to connect to the blockchain. So let's go ahead and set that up while our CLI tool installs the project. All you have to do, oh, look at that, VS Code is already finished. But all you guys have to do is type in the link in the description, and it's going to be tryquicknote.com/cleverprogrammer. So if you hit enter, you should see this nice page right here. Go ahead and put in your information, your name, your organization. You can say personal, you can say, whatever company you're part of, your email, and go ahead and create an account. I already have an account, so I'm just going to sign in. So once you've done that, you should see this nice screen right here. And all you need to do to set up an endpoint is click this button, create endpoint, select the chain that we're using. And of course, we are doing Solana. And the important thing here is that there's 3 networks that you guys should know about when working on Solana. There's mainnet, testnet, and devnet. What I'll say is this: when you're ready for the real deal and you want to use real Solana, right, your own money, you can use mainnet beta. But if you're learning with me, let's use devnet. Okay, so let's use devnet. I'm gonna hit continue, and there you go. There's a couple of add-ons that you could add, but let's go ahead and just hit continue. All right, we'll just hit create because we want to use the free tier. And bam, that's it. This shy, tiniest Firefly, that is our amazing RPC node that's going to help us deploy our contract and connect to the blockchain. All you guys have to do is hit this copy button right here, and we should be good to go. With that said, I think our app is ready. So if I hold Alt Tab here, our CLI tool is going to set up our app. Right? See this? This opened up itself, or at least it should open up itself. So you can see over here, we have our nice app and all of the components inside of it. And since we're already here, one thing that we should do is let's set up our Phantom wallet. If you didn't know, we're going to use Phantom wallet to connect to our app and send all of our transactions and sign them, of course. So what I'm going to do, open up our tab here. And if you don't have Phantom wallet installed, go ahead and type in Phantom wallet extension on Google Chrome. And you can see it should be the first one. It should be this page right here. I already have it installed, so you should be good to go. So if you already have Phantom, skip a little bit ahead of the video. You know what you're doing, right? If you don't, you're new here. What's up, guys? Welcome. So once you have the extension installed, go ahead and log in. You should see something like saving your recovery phrase. That's your password. Don't share that with anybody. Keep it private and to yourself, somewhere safe, right? So you remember, just in case you lose your wallet information. Okay, but you should see something like this, and notice how it says you are currently on DevNet, right? By default, if you just install this, this wouldn't be on DevNet. So what you need to do is go into your settings, change network, and click DevNet, right? Because remember when we set up for QuickNode, which one did we use? We used DevNet. All right, now you guys are following. All right, so now that you did that, you might notice you don't have any Solana, like you're really poor, right? So let's get you guys rich. Let's print all the Solana we need. To do that, just type in solfaucet.com and put in your wallet address. So if you don't know your wallet address, right, just go at the top here. You can see if you hit copy, right, that's going to be your wallet address. So I'm going to hit and paste my wallet address in here. And what you could do, you don't have to do one at a time. You could do 2 at a time. And you're going to click which network? That's right, Kevin, DevNet. I don't know if there's any Kevins watching, but if there is, shout out to Kevin. All right, so back to Solfaucet. Now I have 2. I think I had 16 before. Now I have 18. So do this as many times as you like. You won't need a lot. I'd say for the lottery app, you can get about like 15, 10 even. All right, it's all up to you. So that said, I think we're good on the Solana side. Let's go ahead and check out our app. All right, so going into my app now, you should have everything you need if you did the CLI tool command correctly. Right, all the packages are installed. You shouldn't see any missing packages. It should be set up for you guys. What you guys need to do now is press Command J or Control J if you're on Windows, and let's CD into the app. Once you're in the app, if you didn't know this, to start it, we use yarn dev. Okay, so now our app is running at localhost 3000. Let's go ahead and head over there. And bam, right? If you guys just saw the demo, this looks a lot different than what I just showcased. Reason being is because this is a challenge, right? Why is this a challenge? Because everything works, but we need to make it dynamic. What do I mean? If you guys are familiar with programming at all of this is static data. What do I mean by static? Let's say I click this connect wallet button. Boom, we're connected, but it doesn't actually use Phantom, right? It's just a button that changes what we call states, right? So look at this. These lotteries, it just says 111, right? We can initialize the master, right? We already have the pot for this lottery. We can enter, right? It doesn't really do anything, right? All it does is set up a console log. So let's take a look at that. All right, so we connect wallet, connecting static wallet, initialize the master. We hit enter. We purchase the ticket. We create a lottery, right? Pick winner. It's basically just an empty function that's console logging what it should do. Right, does that make sense to you guys? Cool. All right, so if that made sense, our goal is to give this app some life, right? You saw what it does. How do we make that work? Well, let's first understand, right, what our app looks like. So what I like to do is, just show you, first of all, what our app does. So if we go to our pages, I believe, let's head over to our index. Notice a couple of things here. We have header, pot card, and table. Those are our three main components, right? This project requires you to understand React. So if you're a complete beginner, I apologize, but this might be a little difficult for you. But don't worry, try to see if you can learn something from this. Cool. So like I said, header, pot card, table, right? If we were to draw like a nice visual for all this, let's go ahead and do that. Let me see if I can make this smaller. And let's do my handy dandy notebook. You can just use any other whiteboard, but this is the one I like to use. Perfect. So, as you know, if you are familiar with programming, or at least React, right, we have different components, right? So you can see that this is my underscore app.js. It's returning a component, but within this component, right? Oops, not our code over there. Within this component, we have this, right? This app component has children within it, right? So if I were to draw a little tree to illustrate that relationship, right, it would be a little bit like this. So if I draw a box, this is the app, right? And from there, we have the index.js, right? You guys following so far? You guys know what I mean when I say the child of the app is the index, right? This component is the same as this whole index. So what would be the child or the children of the index.js? What do you think? Give you guys 3 seconds. 3, 2, 1. What do you think? Which one's the child? All three of them, right? So that means index has 3 children, right? So we have 1, 2, 3. Okay. We have, what are the 3 children's names, guys? Should be pretty easy, right? You guys read? It's gonna be header, pot card, and something called table, right? If you guys create your components, the name alone should let you know what the purpose of it, right? So if you look at this, right, what part of our app does header contain, right? If you look at this, which part is the header? Can you guys tell which is the header? Right? If you said this top area right here, you are correct. All right, how do I know? Let's comment out the header, right? Save, boom, the header's gone, okay. What about the pot card? What's the pot card? Boom, gone, right? But with the table, boom, gone, right? What does that tell us though? It tells us that the functionality of each component exists within that component, right? So if I wanna, make it like the demo where you click this connect wallet and you make a phantom wallet connection, which of these components should I tackle? Should I look in the table? Yes or no? No, right? We're going to look at either the header or the pot card, right? If you said pot card, I can understand because the connect wallet button is here as well. But the main way to connect your wallet you saw was basically starts with the header, right? So let's look at the header. So if it's in the header, we can actually go to that very component and take a look, right? And as you can see, the header is very simple. We just have a div wrapper here, a div that holds lottery Dapp, and a button that says connect wallet. So this, right, is where we want to look at to make that phantom wallet connection. As you can see right here, there's something called a wallet multi button that is gonna be our replacement, our dynamic button, right? So some of the imports are set up for you guys already. Other imports, we got to figure out together. Okay, so let's go ahead and figure out how we can connect our phantom wallet to this app. Now, before we get excited about taking this multi button and putting it in here, right? We can't just do that right away, right? Because the important part is we want to connect our wallet to the app. Us putting a button there isn't necessarily going to do that. We have to set up what I'll call the connection provider, right? What do I mean? All right, let's take a look. I was saying that we should put the connect wallet button here, right? But we need to establish the connection to our app, right? So what I mean by that is this. You change it to this board. Perfect. All right. I essentially want to wrap my app with a phantom wallet connection so that anywhere my app is, right? Oops. Anywhere my app is, we have a wallet connection. All right. If I'm in my table, if I'm in the table, it should have access to the wallet connection. If I'm at the pot card, it should know what the wallet is, so forth and so forth, right? We can do this by wrapping that connection provider within the index. All right, so we want to tackle the index component. You guys with me? So if that's the case, let's go back here. Let's open up this, go to the index, and let's take a look. Awesome. So as you can see already, right, we have a bunch of code here. Let's actually make this bigger so you guys can see it. Oops, too big. Awesome. So we have a bunch of code here. We know that this index component holds the three main functionalities of our app. We can put the wallet connection here. It's also okay to put your wallet connection here, right? It doesn't really matter that much, right? But for simplicity's sake and for visual sake, let's work on the index. Cool. So we want to import a couple things. What we do want to import is something called the use memo, which is a React hook from React. We want to import connection provider, import connection provider, right? And if I press tab, you can get the auto import of Solana wallet adapter React. And there's actually another thing we want. Not only do we want the connection provider, we want the wallet provider from the same place. Okay, cool. We also want to import the wallet adapter network, right? This is from Solana /wallet adapter base, right? That's what I believe it's from. So we also want to import the phantom wallet, right? Because what wallet are we using? We're using phantom wallet. There's actually other Solana supported wallets that you could use. It doesn't have to be phantom, right? But I'm most familiar with phantom. I like using phantom. So we want to import that, right? If you are curious to see the other wallets, you can actually look at this library and see the other options. At Solana wallet adapter wallets, right? This library holds all of the adapters. Cool. Let's see, what else do we need? We can also import the wallet modal provider, right? So the wallet modal provider literally sounds like what it says. It's going to provide us with the wallet's modal. So when I click the button, we should see the list of wallets that we can connect to. And it should be Solana wallet adapter React UI. That is correct. And from there, we can just require at Solana Solana wallet adapter React UI slash styles.css, right? We want to get the CSS that Solana comes with. It's that nice blue look that you saw from the demo. So let's get that as well. Okay, this looks pretty good to me. From here, let's use all these imports now. All right, so from order, we want to get the use memo first. Okay, so let's see. Actually, let's make a variable. I want to make const endpoint. Okay, so what is an endpoint? All right, let's say I open this guy up again. Let's say I want to connect to the blockchain, right? Oops, let's erase this for now. I want to connect to the blockchain from my app. And I guess we can make this circle again. Boom, here's my app. And the blockchain, since it's a chain or a block, we can make it a rectangle, right? Solana chain, right? And it's made of different blocks or whatever, right? In order to get our app to connect to the chain, right, we need something like an RPC node, right? And if you didn't know, Quick Node provides you with an RPC node. We could technically make our own RPC node, right? But that requires us setting up some infrastructure, maybe even reinventing the wheel and setting it up, right? I like using Quick Node because it makes it nice and easy to set it up, right? So we want to use our RPC node or Quick Node to connect to the blockchain so it knows what wallet I'm using, right? And if I want to make transactions to the blockchain, we can also use the same process, right? There we go. So how do I use the RPC node? Well, remember I told you to copy this HTTP provider. Go ahead and copy it if you didn't already. Get quotes and paste it right there, right? I'm putting in a variable because it's usually very long. So I want to store it in endpoint so I don't have to like put this whole URL somewhere else. Cool. So now that you have your endpoint set up, let's go ahead and set up our wallets. All right, so we got the endpoint set up. Let's get the wallets, right? Technically, we're only setting up one wallet, but if you did want to set up more wallet options, here is where you would put the rest of the adapters that I was talking about. But like I said, we only have one. So there you go. So let's set up this array here. Oh, sorry about that. Camera died for a second, but we're back. Anyways, as I was saying, setting up our wallets, we're going to put Phantom wallet adapter right here. This is creating a new instance of this wallet. Let's put a comma here. And again, if you wanted to add more different kinds of wallets as an option, you would list them out here. Cool. I'm gonna put empty array right here. And with that, this should be it. Utilizing that React hook, new Phantom wallet adapter, bam. Let's see. Yep, now it's time to set up our connection provider and our wallet provider. So one thing I want to mention is back to our drawing. We want to set up that connection, and this is technically more accurate, but we want to set up that connection. We have to wrap it within our app, right? See how this circle is our connection and it's wrapped within our app, right? To do that with our code, you want to take that connection provider, and put all of our components within that app. This is what we call wrapping, right? We're wrapping the app or header, Packer, and table with our connection provider. So it's wrapped in there. Make sense? So now we're providing the connection, right? Quite literally. Cool. One thing you could do is that you need to provide the connection provider with an endpoint, right? It sounds funny to say. So if I say endpoint right here, right, we're gonna pass in this prop of endpoint. There we go. We're passing in our RPC connection to our provider, which in turn is providing that connection throughout the app. Make sense? That's the way I would explain it. We also have another provider here. It's the wallet provider. Essentially the same thing, but specifically for the wallet. So again, wrap those components in there. Right. And yes, the order does matter if you were wondering, right? It should be connection provider, then the wallet provider, then the rest. Okay, we're almost done using all the imports. Let's see. One thing I'm realizing we don't need is this adapter network. So again, if you weren't using your RPC node and you just want to strictly connect to the DevNet, you would use this import, right? So we don't need that. What we do need is within the wallet provider, I want to use the modal. Again, this is kind of optional, but it's nice having this modal here because it takes a lot of work out of us that we need to set up. You'll see in a second. So let's hit save. Boom. Okay. Yeah, I think that's pretty good. All right, cool. And you know what too? We can even put this div right here, this style wrapper. We can make the connection provider the parent div. What I mean by the parent div is the div that's on the most outside. So what I'll do is take this, put it in here. And don't forget, if you do this, this is the lid of the box, right? You want to make sure that it matches up. Oops. Right here. I took that outside parent div and I made the connection provider the new parent. So our app should look a little bit something like this. If it looks like this, we should be good to go. And we can double check by looking here. Can't read properties of map. That's fine. Okay, cool. This error shouldn't happen, but I'm guessing it's because if we go to our wallet provider, we should provide it with the wallets. So let's go ahead and do that. Wallets is wallets. And if you want your app to automatically connect, you can put this auto connect prop right here. And there you go. No more error. That's what it was missing, right? Don't forget to put your wallets right here. So if you have something like this, if I zoom out, take a look, if it matches up, no errors, we're good to go, right? But notice something, connecting a wallet doesn't actually do something. Not even this one, right? But again, the first thing I wanted to tackle was this connect wallet button. So to do that, which component do we need to go to? Let's go to the header. So I'm gonna go to the header. You see how we're importing this wallet multi button. It should be pretty simple now. If I do something like this, oops, or if I just start saying wallet multi button. Okay, that doesn't work. Let's just do it normally. Wallet multi button. And the wallet multi button is actually self-closing, meaning we can just do something like this. And let's take a look. Hey, look at that. It says select wallet now. And if we have our proper connection and provider set up, we can click on it. You can select, we can see the modal here with all the wallets that we have connected. And it knows that I have Phantom. I'll click Phantom and there we go, right? What functionality did I write to do all this? None. That's what's nice about the Solana wallet adapter, right? We can connect our wallet, we can even disconnect it and it's gone, right? The next thing I want to do is let's put that same button here, right? So let's go ahead and do that. What component should that be in? All right, let's take a look. It should be in the pot card, right? So I hope you guys are getting the pattern because as we go on, I'm going to explain it less and less. I'm not going to hold your hand anymore. All right, I'm sorry. All right, so we're in the pot card and there's some static comments here that we'll talk about in just a second. What we do want is the wallet multi button, yes. And let's go ahead and put it in the right places. So if we look, there's a comment just for you guys that says wallet multi button goes here. So let's say wallet multi button, like so. And there's another place where we need this. And I believe right here, connect wallet multi button. So let's hit save and it goes right here. Perfect. So if I refresh, select wallet, you can even click this button to connect your wallet. And as you can see, it's in both places. Awesome. Cool. Right. And it does mess up our static functions because we didn't set that up, but that's okay for now. What I want to do next is let's actually create the smart contract first, and then we'll get back to this and explain how to put it all together. Sounds good? Cool. So let's go ahead and do that. All right, so to move on to the next step and get started writing our first smart contract together, what you guys should do is we can go ahead and X out this tab. We can make a new tab and we're gonna open up something called Solana Playground. So let me go ahead and make sure we use the full window because we're not gonna look at our app for a while, like I mentioned. So what we're gonna do is type in betasol.pg.io, this right here. And don't worry about this stuff. What we need to do is click this plus button on the side and let's choose a framework. Before I move on, if you guys didn't know, Solana Playground is the place where we can write your very own smart contract. You can build here, you can deploy here, and the most important feature that we're going to use today on this is easy to test all of your functions. Because if you're just coming in, you're not going to know how these work. But the way I understood them, the way I'm getting better at this is by testing and figuring out, what does this do? What does this do? So when choosing a framework, we could do this in native Rust. We could do this in Anchor, and there's new support for Python now, which is exciting. But what we want now to use is Anchor. And let's name this project Lottery Sol. All right, so I'll click Anchor Rust, hit create, and bam, here we go. We get started off with these files right here. This is the default files. As you can see, there's an initialize. But what I want to draw your attention is this macro. It's called #program. This defines a program. So everything within this scope right here that I highlighted is the program, right? We want to create our own Solana program. And just so you know, when I say program and smart contract, I'm going to use that interchangeable, but they're going to mean the same thing. All right, if you're coming from Solidity, this is essentially the remix of Solana. Cool. So let's go ahead and clear this out because we're going to make this from scratch. So get ready for that. So like I said, we're going to be using something called Anchor, which is just a framework of Rust. And if you don't know what Rust is, it's the native coding language to write for Solana, right? So if you see me import stuff in JavaScript, you guys should know that import, use state from React, right? What does this do right here? Well, if you were to write this in JavaScript, this is getting us the use state hook from the React library, okay? So you can't write this in Rust because that's not going to work. It's a different language. So how do we do something similar to this in Rust? Well, the cool part is that you can do this. You can say use Anchor Lang, right? Anchor Lang is a library. And when I say use, you can look at it as import. We're getting Anchor Lang, right? But what do we want from Anchor Lang? So we can get more stuff from Anchor Lang by saying 2 colons, right? If you think of it like a folder, we're going into this folder when I say : right? So we're inside this folder and we can get something from it. We can say prelude, right? So what did we get from Anchor Lang? We got prelude, right? And when I do : again, what's happening? I'm reaching into this folder, I'm grabbing a cookie, and inside that jar, I'm gonna put star. This is basically saying get everything within prelude, right? So you saw me use useState, right? I did this and then useState here. We can do something similar by writing prelude. Get me everything inside prelude. Well, first go into prelude, and then inside prelude, get me everything in there. If I do a comma here, I'm getting more things from Anchor Lang. Think of this is like me getting useState, useEffect, and useMemo, for example. All right, so what else do we want here? Well, we want Solana program : right? So I'm going within this library, and we can get more stuff. So we can get clock : clock, right? We're getting something from here. Okay. We can do a comma. We can do hash, get me hash. And we can get more things here. So we're going to use a bunch of these libraries. Don't worry about fully understanding what all of them is. It's easier to understand all of them within practice. Okay. So system instruction : transfer. Yep. Cool. All right, so this looks pretty good. This is us importing all the libraries we need. Awesome. So how do we create our smart contract, or like I said, a program? Well, to define a program, we have to use the program macro. And again, we don't have to use it, but this will make our lives a lot easier. So everything I write within this macro is going to define what that program is. And maybe if I zoom in, you can see it a lot better. All right, so within here, you say mod, and then the name of your program. So you could call this hello, right? You can say program, right? Which is not a very good name, actually. You can even say lottery, and that's what we'll call it here. So if you do curly brackets like this entire thing that I'm highlighting, that's your program. Not much, right? So keep that in mind when you're making a program. Another thing that you could do is write CP, right? Not clever programmer. Create program, and you can click this and bam, right? And it's gonna do some interesting things, but I don't want you to worry about that right now, right? So you can literally highlight this. It's automatically highlighted. I can say lottery. I can hit tab, change the name of this, blah, 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 change the name of this, right? So I'm gonna erase this because I wanna talk about each thing before I get to it. Okay, cool. So we've made our program, right? But there's nothing in it, it's pretty empty. But let's say you want to import a bunch of other folders in here, or files rather, right? How many files do we have right now, guys? All right, we have one lib.rs. Think of that as the entry point which your code would read, right? But we can make more files than this to separate things, right? Let's make a constants file. Let's write this button right here to make a new file, and we can call it constants. And don't forget to put .rs, right? RS stands for Rust, so like it's a Rust file, just like how we do .js for a JavaScript file. Cool, awesome. So now we have a constants file. But let's say we had like some stuff in here, right? How do we get stuff from this folder into this folder? Well, we can import it, right? So to import that folder, we can say mod constants, right here. And from there we can say use, right? So remember what I said what use is? Use crate, okay? Use crate, colon, and we can destructure it by saying constants, constants, colon, star. So what does this mean, right? Based on everything I told you so far, I'm basically going into my constants folder and grabbing all that's in here. And right now, nothing in constants, but there will be, don't worry. All right, so use crate, if you didn't know, is bringing everything from this file into this entire scope, right? So that means I can call on whatever constants is here, right? But if you want to bring everything from constants into this scope, right, we're going to write something called use super, right? Colon, star. Okay. What this means is that I take everything from that we import and bring it into our program so that we don't have to go within the folder just like we did here. Or we can just call it as it is. All right. If I had a variable, this wouldn't work, but if I had a variable const name and then I said Lance, right? This is not going to run, but let's say I wanted to get name, right? In constants, I can just say name here. Otherwise, if I didn't have use super, I would have to say constants and say colon name, something like that. Okay, cool. All right, so let's erase that because it's going to break our code. Cool. And let's recap something, right? Another important thing about Rust is, look at this. This is a semicolon, right? In JavaScript, we can get away with this, right? They're pretty lax with you in JavaScript. In Rust, this marks the end of the line, right? After you see the semicolon, your code is like, yep, that's the line. Otherwise, it's going to think that this whole thing is one line if I didn't have this semicolon here, right? So you need to put semicolons. If you don't put semicolons, your code will panic. So make sure you do that. We're going to need it for this use super as well, right? And use anchor lang should be like this as well. Cool. Awesome. So going between our use crate and our program, we also need to declare ID, right? So if I press D, if you press DI, we can press declare ID. So I clicked it and it generated this for us. This is the address of where our program is, right? You can think of it as the address of where it lives. And if you see all these ones, that's the default essentially, right? When I go ahead and build this, we'll get our new program's public key. So don't worry if it says 1, we can leave it blank for now. But now it's starting to look a lot like the starter files, right? Cool. So the next important thing you need to know is, how do we make a function in Rust? How do we do that, right? In JavaScript, you would just write function, right? Function, and then say init, right? In Rust, kind of similar, right? All I have to say to get started is say pub, fn, init, right? I'll even call this init master because that's what we're gonna have to do in a second. And that's how you make a function, right? So what's the skeleton? You need these parentheses. And you guys should know, if you know anything about programming, is this is where you put your arguments. Okay? Cool, so what's next? Are we done? Not necessarily. All right, what we need to do is press this dash right here, a greater than sign to make an arrow. And then you say result, less than sign, parentheses, greater than sign, curly brackets, and bam, that's it. This right here that I'm highlighting, this is a function. or an empty function, right? It's a skeleton of a function. All we need to do now, right, is write the logic in here, right? So this should look more familiar to you. It's not scary Rust right now, right? What are some other parts of a function? Usually there's a return here, and we can return the number 5, like if this was whatever adding function, right? But in Rust, we're going to return OK, right? This is not exactly return, but it does give us back something. And if you didn't want to give back 5, if it works, you put 5. But for this specific function, we can leave it as is. Okay? You with me so far? Right? Because you're doing great. This is it so far for the function. What do we want to do with init master? What does it all mean, right? So if we think back to our app, right? We're connected here. Let's see. What I'm going to do is temporarily remove this button over here. So let's go to our code. Code. Right here. Let's see if we can make this bigger. Nice. And where is that wallet multi button? Comment it out. Save. Boom. Wait. Oh, it might not be even running. Let's try and make it run. Yarn dev. Oh, cd app first and then yarn. Okay, we're good. We're back, guys. So let's refresh this. Oh, I see, because it can't be empty. That's totally fine. We'll just put button here. Button, and I believe there's an on click. And we had a temporary function here, which was connect wallet, I believe. Connect wallet, yep. So I'm just gonna temporarily put this back, connect wallet. There you go. Oh, did I change the wrong one? I did. Connect wallet. And let's bring this to the other place. Right here. There we go. Okay. So remember what this button does. We connect our wallet, and this is the next thing we should see. Initialize the master, right? Because once we initialize the master, we should have access to all the things, right? So the real question I was asking is, what is the master, right? So the master is going to be an object, right? This is what it'll look like in JavaScript. That's gonna hold the last lottery ID, right? Why is that important, right? Lottery ID. Because if you look back at our app, this current lottery is number 3. At some point it was 0, some point it was 1, some point it was 2. We need an object to keep track of what lottery ID it is, right? The reason why I'm making a master object is because this guy will do it. And if we do it correctly, we can have multiple lotteries going at once. It doesn't have to be one at a time, right? So this is perfect for that. For the purpose of this specific video, we will work like it's one lottery at a time. If you're more advanced, see if you can make multiple lotteries come at once. There's no front-end support for that, but that's my challenge to you guys if this is too easy for you. So yeah, we want to make a master object essentially and initialize it here, right? So there's a lot of pieces that we're going to need. Cool. So before I get into the rest of it, an object that holds the last lottery ID, right? Before I continue writing out the answer, another thing about functions is that there's usually context as a parameter, right? So let's say when we're adding two numbers, it would be num1 and num2, right? For every function in Rust or Anchor, we need to write CTX, which stands for context, right? We got to give this function context to work with. Like, what is a master? That's what it needs to know. So we have to pass that in, okay? Another thing about Rust is that you need to identify the type. So remember my example of, like, let's say we wanted to get the name. What data type is name usually? Can you expect? Right? It would be string. Right? You gotta let Rust know, like, hey, there's gonna be a name coming in, and he's a string, by the way. Right? kind of like the security guard. So context, right? It's not going to be a string or a number. It's going to be a struct called context, right? And it's going to look something like this. And you put your variable in here, in this where the t is. Okay, cool. So our context is usually the name of our context is going to usually be the same name as the function. Doesn't have to be, but it should, right? So if it's the same name, we can call it init master. Okay, and whenever you're not really using it or doing anything in a function, you put an underscore here. Okay, cool. And there's a reason why we don't have to initialize it here, but don't worry about that. So far all we know is we made a function where we put okay here. This is our result. Our logic goes in here, and it needs a context, right? But if I were to ask you guys a question, does init master exist? Does this context struct exist? Yes or no? No, it doesn't, right? What did I get right there, right? Init master doesn't exist yet, right? So this would be like undefined, or more like this is undefined. So how do we figure out or make our code understand what is init master? Well, you want to go outside your program, come right here, and let's initialize it, right? So let's talk about accounts. So what are accounts? Basically, with our Solana program, we can create something called PDAs and essentially store data at these accounts, right? So how it look, if this is the Solana chain, right? This rectangle is our program. We can use this program, right, to generate accounts, and each of these accounts will have their own public key, right, or their address. But within the public key, we can put account data, right? Or in other words, the master account. Okay, and what does the master account hold? It holds lottery ID. Okay, so later on, what we're gonna do is fetch these accounts into our app, right, and use them and plug them in to make this work. You following so far? You can think of this as a database, right? Because it is a database that's decentralized, and we can fetch all of the objects, right? I'll call them objects from the chain. All right, it'll make more sense once we actually make it. All right, so to actually create an account in Rust, we're gonna use a macro. We're gonna say hashtag square brackets derive parentheses accounts, right? So this makes sense. We're deriving accounts here. We're creating a PDA, and we're saying pub struct, right, init master, okay? And then from there, you're gonna say less than, greater than, and write info like this with one apostrophe, and that's it, right? This is called a lifetime variable. This, you know, without making it too complicated, we're gonna just make sure that this struct will live on for however it needs to in our app, right? Because in JavaScript, if I were to make an array, let's say let array, right? How long would this live in memory? This would live forever until I'd like delete it or clear it, or the heap garbage collector from JavaScript destroys it, right? When I put a lifetime variable, you let your code know, hey, this is gonna last for this long. He's staying at this hotel for this long, right? I'm not defining exactly how long it's staying. I'm just saying it's gonna live as long as it needs to. Cool. So how do we actually make an account? All right, boring coding stuff, I know. But to actually make an account, we need another macro within here, right? And remember, every time you use it, what you write under it is where this information is gonna get put into, right? So within here, making a macro, and we're gonna write account, okay? And then we're gonna say parentheses, enter, right? And the cool part about Anchor is that it initializes an account for you, and all you need to do as a developer is just write init. Boom! You just told Anchor, hey, initialize init master struct, right? Well, actually, no, it's gonna go under here. So this is a struct. This is our context of our code. I want to initialize a master account. So if I say pub master here, does that make more sense? This macro is gonna initialize a master account, okay? So init will initialize payer equals payer. Okay. The reason why I'm writing payer is because whenever you store something, you store something on the Solana chain, right? You got to pay for it, right? This isn't free, right? You have to pay for the space you use, kind of like rent, right? If you're gonna stay somewhere, you got to pay some rent. Okay, so get used to that concept, and don't worry, it's not expensive because we're on the DevNet, so it's essentially free, right? But it's usually cost like 0.000000 on the DevNet, so don't worry about it. But the payer is gonna be payer, which is us, all right? The wallet that puts this here. Okay, that's all you need to know. And then we have to define how much space does this actually take. I'll let you know. It's gonna take up 4, right, plus 8. Okay, don't worry about this just yet. I'll come back to it. Next thing that's important though is we need to put seeds. All right, what are seeds? All right, so remember before how I said when we were generating a new account, right, it's gonna have its own address, right? But we can predictably find an address to put this data in, right? We just have to put something as a seed. All right, the best way you can visualize this, it's not the same thing, but the best way to visualize this is there's something called dice bear, right? Notice how it says put your custom seed here. If I put the string Lance, put Lance, it generates a unique avatar. This is my avatar right here, right? But if I were to say Lance with 2 E's, notice how it's a completely different avatar, right? So depending on what seed you get, you'll arrive at a different address or public key, okay? Cool. So what I want to put here is a string as well. So you can put a string. What I'll do is I'm gonna call a variable. And what do I mean when I call a variable? Let's make use of our constants and let's write pub const master seed, right, colon, right, because it's expecting the type, and string, and it's gonna reference itself, right, and it's gonna write master and semicolon, right? Cool. So master seed, right? This lives in constants. We bring that master seed using use crate to bring it here. We use super to bring it in this scope, right? Just in case, but we don't need that, right? Our crates. So for the seeds, if I write master here, right, you guys should know what I mean. This is a string. It's a variable that holds this string. And usually when you put something in this array, it wants it in bytes. So if you do dot as underscore bytes, it will convert it to bytes. Okay, take that string, convert it to bytes. That's the seed. Okay. Yep, master seed. Oh, and I just put master. It should be master seed, like this. Cool. Yeah, make sure it's the same name as this. Awesome. So we have our seed, we have our space, and now let's add bump. If you don't know what bump is, let's say when I'm trying to put it in this little account, there's already something there, so I need to put it somewhere else, right? It's kind of like saying, oh, there's already a Lance avatar that exists. If I put a 1 here, we'll put it there instead. But what if that don't exist? And we'll put another 1 here, or a 2, right? That's what bump is doing. It's checking the next available address that it can do. All right, I'm very simplifying this, but that's all you need to know for now. And all of that information is related to this master right here. And what type can we expect from master? Well, it's an account, right? Because we want to initialize an account, right? Cool. And again, if you didn't know where account comes from, it comes from anchor lang. So all of our imports are important. And how long does this account live for? I don't know. We're going to put info here, comma, master, right? Master is essentially what this account is. What account is this holding? What's in this account? A master account. But if I were to run this, guys, it doesn't exist, right? How do we make it exist? Well, we have to create it. So let's create a master account, right? So to make a actual account, right, we need to define what a master account is. And I kept calling it an object because that's what you guys coming from JavaScript are going to relate to. So put hashtag account like so, and then you're going to write pub struct master like this, and you say pub last ID is U32. Okay, cool. All right, that's it. We're done. We made an object, right? So what's the equivalent of this? You can kind of say like master or class master is something like this. constructor, it's been a while since I made this, right? This dot last ID is equal to like nothing or empty, right? I made, what would this make, right? This would make a object that has a last ID, right? So this class master, this struct master, will make an object that has last ID. And does this have a value? No, it has no value in it. So we need to basically initialize it with a value later. Okay, so cool. I hope this makes sense because we're going to be doing this over and over. Like anchor, once you recognize the pattern, it's pretty repetitive. So keep that in mind. So now master exists. Don't think there's anything else we need to add, but how much space does a U32 take? It's going to take in 4. So that's why for how much space we say, hey, there's going to be a master account that's coming in. He's going to take up this much space, 4. And this 8 is kind of like the filler space. This is called the account discriminator. So you'll always see me add 8 to everything. Okay, cool. Another thing that we're going to need is we're going to say hashtag account mute pub payer is going to be the signer, and this signer struct is coming from a library as well. This is so that we can define what a pair is, so that the pair does actually in fact equal the pair. Okay, then you can add some space here and say pub system program is the program itself, info system, right? Cool. And don't forget to add these commas here because they're kind of important. All right, so if it looks like this, we should have our context. And again, I put an underscore context because we're not really doing anything with it. It's going to be blank. And we should be good to go. So let's do the moment of truth. All right, we can go to build and let's run it. So we build, there might be some errors as you can see. All right, so usually if you see a bunch of things, it might be something to do with the first one. So it says pub program not found in init master. Okay, cool. So let's figure out what's going on. I'm guessing it has to do with the semicolon or something I forgot. So I'm taking a look around and the first error is expecting a comma, line 27. Comma, oh, I see, there's no comma right here. Cool. So let's go ahead and click this brush thing to clear it out. Let's hit build. Okay, more stuff. Now it says something wrong with init master. Okay. I have a feeling it's another comma thing, comma. Oh, there's one right here. Build. Hey, okay, build successful. Cool. So I'm gonna press this brush. Let's build again so you can see the successful build. Awesome. So I forgot a comma right here. Now it's good. Right, if you see warnings, that doesn't mean it's not working. It's just our code warning you like, hey, you imported a clock, but you didn't really use it yet, right? But that's okay. We can live with the warnings because eventually we will use those clock, okay? So other than that, we're good to go. So all you have to do, if you haven't done so already, if you're your first time using Solana Playground, connect your wallet here. I don't know why the brush is really big. But click this toggle Solana wallet button. Once you do it, it should say connected, right? If you didn't know, this browser already comes with a wallet, so you don't have to connect your Phantom, but you can if you want to, right? But if you want to deploy, use this right here. You probably don't have any Solana either, so all you should do is go into your terminal and type in Solana airdrop 2. Right, this is the same thing as the Solana faucet. It will give you 2 to deploy it. Right, cool. So again, what's happening right now? Well, essentially, we made a smart contract. Right, we want to deploy it to the blockchain so that we can call it from the blockchain back to our app. Right, so what step are we in? We did this part. We wrote some code like this. Right, and now let's deploy it. Let's X out this dice bear. Deploy. And it usually takes a couple seconds. Nice. Okay, deployment successful. There we go. Cool. So what does this mean now? It means our code successfully lives on the blockchain now, right? So now that that's a thing, we can test it. So the cool part that I like about Solana Playground is that if you click this test tube right here, we can test all of the functions that we create so that we can get a better understanding of it. Now, one thing you'll notice to start understanding this is we have some accounts, right? It recognizes, hey, it's going to create some master accounts. But if I ask you, since we just deployed it to the blockchain, how many master accounts do we have? I'll give you guys 3 seconds. 3, 2, 1. Ding, ding, ding. If you said the answer is 0, fetch all, you are correct, right? We can fetch all of the accounts that we created with this program, and you'll notice that there's an empty array, which means there's no masters. How do we create a master account? Well, remember that we initialize it in this context, but we have to run that function. So we need to do init master. Okay, so let's run it. But we can't just run it, we need to pass in some things, right? See how it says accounts here? All of this is equal to the context. This is our context, right? What we gotta give our function some information, right? So the accounts that we need to give to our function is a master account and a payer account. So let's scroll down. Where is master and payer coming from? How does it know? Well, if you look at our init master context, what's there? A master, a payer, and a system program. Master, payer, system program. And if I remember what I told you guys, let's start with something easy. I told you guys that the payer is us. So if you click this, click my address, that's us, 6D. If I click this wall here, 6D, that's my address. It's gonna be different than yours. Make sure you click my address. The system program, it's gonna be all this ones, right? Because that's gonna be default. It's gonna be set up for you already. You typically, at least when we're on this browser, don't have to write anything. Now, for the master, you basically have to tell your function, hey, where are we putting this master account, right? Remember, where are we putting this master account, right? Are we gonna put it, oops, not that one. Are we gonna put it here in this rectangle, this rectangle, this rectangle? How does it know? Well, we can predict it by using our seeds, right? So what is our seeds? Well, if you look at our seeds, we need to just say our seeds is the master seed. But what is master seed? It's just a string master. So what does that look like? Click in this input field, click generate a public key from seed, and make sure it's string, it usually is. And all you guys have to do is write master, generate, boom. That's it. Right, see this 7RX? That's the seed that generates from us writing master, right? So that's the place we're gonna put it. So if I press test, it should create a master account. Let's go, it passed. All right, that's a good sign. So it passed, which means we initialized a master account. How do I know? If I do a fetch all, boom, there it is. In this array, there's one object with 2 properties. One, the public key on where it lives, and also the account with the last ID. All right, how's that? Also, by the way, it says the ID is 0. So when we first start, the first lottery should be 0. Cool. So I hope it made sense. Every time we make these functions, if you're confused at all, wait till I test it. Right? Testing is the key here. So this is level 1. We're only going to increase the levels. It's going to be just like this, but we're going to add another layer to it. So if you guys are with me, drop a like in the video. Put a comment below, say that I'm helping you out. Solana is awesome, right? Also, shout out to Acheron. He's the developer who made this website that helped me learn Solana. So let's keep it moving. All right, so I think you guys get the idea. Time for the next function. All right, so another function that we need to make is we made the master. Let's create the lottery. All right, we need to set up the lottery, right? If we go back to our app, what happens? Let's refresh this real quick. What happens statically at the moment? We connect our wallet, we initialize the master, and then we can create the lottery, right? Because if we don't create the lottery, what are we even playing, right? So we got to do that. So let's create the lottery. How do I create a function? Well, you say pub fn, name of function, which is create lottery. Cool. What else? Parentheses, arrow, result, boom. And then after the result, curly brackets, this is your function. All right. You guys know who Kabi is from TikTok? That's a function. Okay. So from there, let's go ahead and write CTX because we need context, right? And then what is context? What type is it? Well, context is context. Oops, don't write it like that. Write it like this, context. And what kind of context are we expecting? We're expecting a create lottery context. And if I were to ask you guys, does this exist yet? You have to say, no, Lance, it doesn't exist. So what do we do next? Let's create the lottery, right? And again, the whole point of this is to, let's write what we want to do. We need to create a lottery account, right? So what do we want to do this? What is the lottery account before we go any further? Well, lottery account, it's going to hold the current, let's ask the question. What is a lottery account? Well, the answer to that is it holds the ID, the winner, the winning address, right? Whatever address wins, the total prize, right? And sorry about that, let's make this smaller. The total prize, and it also holds, I'm thinking, if the prize was claimed, and who has authority over the lottery, right? Authority is basically who controls the lottery, who created it. All right, so that means, in short, there is a lot of things that we care about in this lottery, okay? So we need the ID, the winning address, the total prize, if the prize was claimed, and who has authority over the lottery, okay? You guys got all that? Cool. So we can't do anything here just yet because we need to create the context. So let's go ahead and do that. So we can go ahead and create the context. And how did we start last time? This is why it's repetitive. We have to start with that, right? Just say hashtag, square brackets, derive, accounts, pub struct, create lottery. And this is the last time I'm going to be writing it and typing it myself. I'm going to show you guys how to use the shortcuts after. Okay, so create info, create lottery, and then put info, put these curly brackets to identify the scope. Cool. So let's set up another account macro here. And before I move on, all of the information that comes in here is going to be coming to the lottery because we want to define what a lottery account is. Okay, cool. Oops. So how do I initialize an account? You write init, right? How do I define who the payer is? Last time we put payer, right? But the difference between the master and the lottery is that there's an authority. So the payer should be whoever has authority over this. And again, just like how payer was a variable that we made later, authority is going to be a variable we make later as well. So let's go ahead and not forget the commas this time. And for space, we'll leave this blank for now. For seeds though, put that array. What did we do last time? We had a variable that holds a string. We can do the same thing. We don't want to put master seed because that would generate the same PDA. We want to put lottery seed. All right, and does lottery seed exist? No, but that's okay. We can make it. So let's say pub const lottery seed. Make it exactly the same thing, which is a referenced string, and we say lottery. Okay, wonderful, wonderful. So master lottery, I think we're good with that. Cool. So lib, boom. So lottery seed, but we also need to turn this into bytes, right? So to turn to bytes as bytes, boom, cool. And we can do comma bump before I do anything else. But one thing I want to say is for the creating a lottery, we should have more than one seed, right? Because the more seeds we put into this, right, the more unique of a PDA we can generate. Okay, and again, we're not making new addresses. All these addresses exist already, right? But we just want to make sure we select a predictable one, right? So right now, the only seeds is the lottery seed, which just says lottery. We can also put a comma here to add more, and we can say, we can do master.last ID, right? So what's master.last ID? Well, let's look at this. This is master, right? This account dot last ID gives us 0, right? When our lottery is at 1, technically the seed will be at 1, right? So let's do that. And again, when we create a lottery, we need to add 1 to it. So that's why it's whatever the last ID is plus 1. So technically, if this is 0, this will give us 1. Okay? And we want this to be formatted the way it can read it. So let's say 2 LE bytes. Awesome. Cool. So now we have some jack seeds in here. We have the string and essentially the number, right, of +1 as our seeds. And that's going to help generate the lottery account. So again, what type is lottery? Well, it's an account, and you can say lifetime is info. And what type of account? It's a lottery account. But does lottery account exist the same way master did before? No. So let's make it. And again, to make it, same structure, account pub struct lottery. And now let's define the object. What do we need for the lottery, right? Just in case you forgot, we wrote it all down. It needs an ID, the winning address, the total prize, if the prize was claimed, and who has authority over the lottery. And again, it doesn't necessarily have to be in that order. So let's write it out. Pub ID. Cool. So I'm saying, hey, every lottery account will have an ID. Then your code's like, hey, Lance, what's the type of that though? Well, it's going to be U32. And if you didn't know, U32 means unsigned integer 32 bytes, right? If let's say, the way I understand it is that if you do U8, that's a small number. But if it's like 900, U8's not a good number type to put. You should put 32 because I feel like that's gonna be enough. Okay, let's put authority, right? Who has authority? It should be the person who created it. So what we could do is write something called pub key, right? Because the authority is going to be whoever created it. In this case, it's this address, which is a type public key. Okay, you with me? Cool. So the rest of this should make more sense. Pub ticket price is next. Okay, so this one I forgot. This isn't the total. It's got total prize. It's the ticket cost. All right, how much does each ticket cost? What's the price? Okay, and for this one we can say U64 because I want it to give us a range of numbers we can use, a bigger range than however numbers ID can go up to. So 64 bytes. Okay, cool. So U64. We also need the last ticket ID, right, which will be U32. And before I move on, just so you know, there's a difference between a lottery and a ticket. Duh, right? So every time there's a lottery, we can purchase a ticket, right? We should also keep track how many tickets there are. So if the last ticket number was 0, the next one should be 1. The last one was 1, it should be 2, right? Because later, when we pick the winner, we're going to select a random lottery ID and figure out what the pub key associated with that ID is. Cool. That was a different language to you just now. Don't worry about it. Cool. So later on, we want to establish who the winner ID is, and the type of this is pretty interesting. It's called an option, right? An option. Okay. And this is unique to Rust. Like you've never seen this before in JavaScript, but make sure it's type option and claimed. All right. I want you guys to answer this. Claimed. What does that mean? Did the winner claim the prize, right? Did the winner claim the prize? What kind of type should that be? I'm gonna give you 3 seconds. 3, 2, 1. Did you guess it? It's gonna be a Boolean. So to make a Boolean type, say bool. Awesome. Okay, cool. So we made the lottery account. That's it. There you go. There's the account. The context is almost done. We just need to put pub authority. Well, actually, we need the macro first. Account mute. Then we can put the macro, the authority, and say pub authority is the signer, right? So again, this is just the naming of it. It's the same thing as what we did with pair, but this time it's authority. Okay, you can put pair if it's too confusing. Cool. And the last one we need is system program. All right, again, you could copy and paste this because, again, same thing. Cool. So that's a lottery. Moment of truth. We hit build. Cross our fingers. Okay, of course, we forgot something. There's our warning. The first arrow is info is never used. Line 52, create lottery. Okay, cool. So authority. Oh, how could I forget? I said we're gonna come back to space, but I freaking didn't come back to space. All right, so basically, to determine how much space you're gonna use, each of these things, each of these types will take up a unique amount, right? One way to think about it is a U32 will take 4. Right, so how many U32s do we have? We have about 3. So that's how much space it's gonna take. So we say 4, well, we can do the 4 plus 32 plus 8 plus, 8 plus, what else do we have? 4 plus 4 plus 1 plus 4 plus 1. All right, cool. Yeah, U32 is going to be for the 64. This 8 here, I'm going to put at the end. Plus 8. So we have 4 plus 32 plus, oh, we actually do need an 8. Now I'm thinking about it. So we have 4, 32, 8, 4, 1, 4, 1, and then the account discriminator. So yeah, all of this is how much space the lottery takes. There's something weird though. This should be highlighted the same way this is highlighted. So that's pretty weird. Oh, there should be a comma here. That's the first thing. Oh, and there should be a comma here. And there we go. So now I could tell this time the error is because of the colors. So let's see if we build. Okay, cool. Right, so again, we're gonna get an error because the function's not done. So we have our context, create lottery. We have our struct or our account lottery. We need to use it. So again, this is different from init master because we didn't do anything here. Here we can actually, we should write stuff. So when we're creating a lottery, right? Let's make this smaller. What we want to do with this function is initialize the account, right? Basically, give values to this because this should have the last ticket ID and so forth, right? And now that I think about it, we might be missing one more thing. Are we missing anything? Create lottery. Oh, we are. We also need access to this master account, right? Or the master account that's associated. So just like how we initialized it here, like this, we can bring it in our code right here. We can say hashtag account, right? Oops, and say mute because it can be different. Seeds, right? So remember how in the master we were able to generate the corresponding master based on the seed. We can do that here as well by saying master seed bytes. All right, so this should give us the same master. We can say pub master, tell him what type. It's gonna expect an account, info master. Cool. Couldn't forget that. Seeds. And we can just do bump. Cool. And again, we don't need to initialize here or tell them how much space it needs because we already set it up earlier, or it should be done by the time we can create a lottery. So we have access to the lottery account, we have access to the master, we have access to authority, and the system program. So we need to, all of that, all what I just said exists when I write CTX. Okay. So how do we use this? Let's think about it. So CTX is essentially all of this, right? When it's kind of like an object. So how do I get the lottery, right? So to get the lottery, all I do is type in ctx.accounts, right? And once you do .accounts after CTX, you have access, right? Keyword access. And I put a comma here, comma. That's good. Access to lottery, to master, authority, and system program. So let's say I wanted the authority. All I have to do is ctx.accounts.authority. Right, but which one did I want? I want the lottery. So if I say .lottery, now it's the same as getting the lottery object, right? So I have access to all this stuff. What I like to do is set it equal to a variable. So we can say let lottery is equal to all that. Okay, so now when I say lottery dot is what's called last ID, right? You know what I'm talking about now. Yeah, or better yet, lottery ID. I can set this equal to 0. I can hard code it. Or I can even set it to 3 or 4 or 5. Right. Another variable I want to set up is let master. And do I have access to the master accounts? Yes, I do. That's why I set it up. So if I do CTX, I can do .accounts, and then I could do .master. Store it in that variable. Cool. So what do we need to do? Well, the first thing I like to do is, remember when we make a master account? Oops. When we make a master account, it's only keeping track of the last lottery ID, right? So when we create a lottery, we should increment that. So we can increment that really easily by saying master.last ID plus equals 1. This is JavaScript, or we know this, how to do this in JavaScript. It's the same thing, right? Increment the last ticket ID. And again, if you're more advanced, you know how to do this. If you switch the branch on the repo from CLI Starter to main, I've included the solution so you can compare it to that as well. Okay, so move on right ahead if this makes sense to you. If you're a beginner, don't worry, stick with me, you'll learn. Cool, so we increment the last ticket ID. Next, we want to set the lottery values, right? So currently, lottery.id is empty, but what should it be? Right? Should it be 0? Should it be 1, 2? Well, it should be whatever master.last ID is. So if you know, you can just say master.last ID like this. Okay, we're literally pulling it from here. So we increment it. It was 0, now it's 1, and now I'm saying the first lottery ID is 1. So if you were to reflect that here, technically the first number would be 1, 2, 3. Okay, cool. Next thing I want to do is, who is the authority? So we say lottery.authority. Well, the lottery.authority should be us. But do we have access to that? We do. Right, so go back to your context, check if we do. We have it right here. So how do we get this? Think for a second. So I want to try this on your own. 3, 2, 1. All right. If you said to get the authority, you say ctx.account.authority, you're correct. But it's not a public key, or not in the format that you want right now. What you want to do is .key, and there you go. You got it now. So that's the authority. Okay. Next thing you want to do is lottery.ticket price. All right. How much does a ticket price cost? Well, this one, do we have any information about that? No, we don't. Right. how much does each ticket cost on this specific lottery, right? We can pass that in as a variable or a parameter. So we can write ticket here. And let's see, do I need to do anything? Yeah, ticket price. And this can be a U64. All right, so this takes in 2 arguments, the context, which it always does, and ticket price. So technically it takes 1 plus the context. Okay, so then we could take this argument and use it here. Ticket price. Ticket price. Amazing. Okay, cool. Lottery.ticket price. Cool. One cool thing is that we can add messages. Right, I imported this library. We can say created lottery or created lottery. This is kind of like when you see a message like this, think of it like console log in JavaScript. I'm basically saying, hey, this is the created lottery, which is going to be lottery.id. Okay. The reason I write it like this is because if I say lottery ID here, it's going to go where this curly bracket is. So basically we'll say created lottery is 1. Okay, another message. The authority, right? So how do I define what the authority is? Curly brackets, comma, lottery dot authority. Nice. And we can also let them know what the message is. And I forgot, every message needs an exclamation point like this, the bang. And the ticket price, colon, curly bracket, and let's fill in that curly bracket with lottery.ticket. How do we get the ticket price? Ticket price. Okay. It's funny I said okay because that's what we need next. Okay. Whew. All right, that was a way bigger function than init master. Yeah, guys? Well, but this is what we need to do to create a lottery. First, simplify the context into variables, increment the last ticket ID, set the values, and again, optional, but we can write little messages here. So let's take a look. Clear that, go to build. Got one. Is this an error? Could not compile. Results found. Okay, let's see what's going on. Let's make this smaller and let's take a look. I wanted to see this again. Ticket price, ticket price. Oh, I wrote ticket price, but it should be ticket price. Okay, that was my fault. I wrote price here, but it should be price, I think. What did I put here? Ticket price. Okay, let's build. Ah, another important lesson. Okay. So if we go back here, one thing I forgot is that in Rust, we can't just say equals this if we're going to change it, right? Remember const in JavaScript? Right, we can't change variables that say const. In Rust, it's even more strict because if we want to change a let, right, you have to say and mute. Right, so let's make sure we add the and mute because this means I'm making this variable mutable and that it can change. Otherwise, it's going to assume that it's going to stay that way. Let's go, build successful, right? So let's clear that. Let's show you again. Nice. Again, warnings, totally fine right now. I'll use the clock, I'll get to it. But there we go. I'll ask you guys this. We deployed our smart contract on chain, right? But when I add new code, am I writing that on chain? Yes or no? Am I writing here? No. Essentially, we still have our copy here. And we wrote that first function. But we just wrote a second function, right? We want to upgrade this contract, right? The cool part about Solana is that you can upgrade it. Usually when it's on a blockchain, you can't delete stuff or rewrite stuff. But we can by pressing this upgrade button. And this will cost you some soul. So make sure you airdrop yourself a lot of soul. I think this should be enough for me. And once that's done, we run the test again. right? And this is the process. You figure out what you want to do, create the function, create the context, get what you need in that context, and you're good to go, right? So you can make any function this way. And I encourage you guys to try it. Make your own projects, test this out, learn from this, right? We have the create lottery function now. So again, currently, if I fetch all, we still should have one. Even though I upgraded it, I didn't make a new smart contract. I still have the same address. And this is still a account made with this from this address, right? But do we have any lotteries, right? No, I have none. But let's walk through the hypothetical. If I create a lottery object, right, a lottery account, it should be filled up. But does this get changed? Yes or no? Yes, right? The last ID gets incremented, right? How? We did it right here. So let's put my theory to the test, right? We need to put a ticket price. Cool. So let's determine how much each ticket will cost for this lottery, right? In an ideal world, we could just put 5. It costs 5 Solana to enter the lottery. But when we're testing this, it should be in what we call lamports, right? So what are lamports? Well, you know, the native token for Solana is Sol, right? Well, if I say lamports, lamports is a fraction of Sol, right? So a bunch of lamports, like a lot of lamports, will create 1 Sol, right? So let's say I want to make this lottery cost 1 Sol, right? To do that, you would write 9 zeros, 0, 0, 0, 0, 0, 0, 0, 0, 0, and you put how much Sol right here. So if I put 5, this will be technically 5 Solana. But for the sake of how much Solana I have, I only have 5.8 in this wallet. I'll put 1. Okay, cool. Now, again, let's do the easy stuff first. We did the arguments, right here. What accounts do we put in? This is coming from where, guys? The context, right? We need to define the master, well, not this one. We need to define the lottery, the master, the authority, and the system program. System program is done for us, but who has the authority? Who's paying for this? Me, my address. The master. Do I need to generate a public key from seeds, or do I have something already? Right, I do. I already have a master right here. So go to the public key, double click this, Control C or Command C, and paste that right there. Right, this is the master that we're gonna base off to create the lottery. Right, so now for the lottery account. Does a lottery account already exist? Yes or no? Right, you should say no here. Why doesn't it exist? Because we generate a lottery account from the seed. Right, so let's do from seed. So the first thing is lottery, right, and the next is whatever the master's last ID is, +1. Right, so you select that, right? It's gonna be in U8, should be. Yep. And actually, now that I think about it, let's remove that. Let's add a U32 here. Why do I want to add a U32 here? Is because it's expecting a U32 anyways. All right, so let's keep it consistent. And what is the master's last ID? Let's check. It's 0, but the trick here, the gotcha, is this +1. So what's 0 + 1, guys? Yep, thank you. It's 1. Good job, Sarah. All right, so now we generate, boom, it calculates the public key. We got the master, right? And if we wrote everything right, the test should pass. Let's go, right? I'm always a little nervous when I run the test because maybe I wrote something wrong, as you saw before, but the create lottery passed, right? So when I fetch this, how many accounts should we have? Boom, 1, right? So notice something. Remember how we defined the winner ID to be option, right? It's either going to be null or it's going to have an actual winner here, right? But we need to create a winner function first in order to see that in action, right? And again, this doesn't cost like $1 million. This is equivalent to 1 Solana. We're going to make that conversion later, right? Because again, this is in lamports, right? Fractions of Sol. Okay, so it should be 1 Sol. Who has authority, right? This guy has authority. And what is that? All that means is he can pick the winner, right? Because it'd be weird if other users can pick the winner. The ID is 1. And now my question to you guys, if I get the master, if I fetch this, what should this last ID be now? It's 1. Cool. So how many lotteries we have ongoing? Currently 1, right? And it won't be ongoing until we have a winner and they claimed the lottery. Cool. So that's the create lottery function. All right, so let's continue on. So we just made the create lottery button, but what other functions do we want to make, guys? All right, let's think back to the demo. What did we do, right? We connected our wallet. We can initialize the master. We can create a lottery, but we also need to enter. When we talk about enter, I mean, let's purchase a ticket and add to the pot, right? So if every ticket costs 1 sol, after I press enter, what should the pot be now? 1001, exactly. Okay, so with that in mind, we need to create that functionality. All of our functionality is coming from this smart contract, right? You know, it's different from when if we were to make this in just pure Next.js, we would put all that functionality there. It'd be really easy, right? For us, we're just gonna say pub fn. Okay, we say by underscore ticket, because that's the function name. And excuse me, let me just move that over. By ticket, set up the function. Cool. And what else do we need, guys? We need context. So let's say ctx. And this is the last time I'm writing out this function. So ctx context. What is the context? It's the by ticket one. Okay. I'll let you know right now, this by ticket, it's going to take in the lottery ID. All right. What lottery are we buying a ticket for? That's why we need this. Okay, cool. That's set up. We need to set up the context now. So let's go scroll down to the bottom and create that context. All right. So we want to buy a ticket. How do we start? Well, we can go and say derive accounts. Derive accounts. And we can say hashtag. This is kind of new. This is an actual instruction. So we say instruction parentheses, and we want to pass in the lottery ID. And type U32. Okay, and then underneath that we say pub struct by ticket. Okay, what do we put here? Info and curly brackets. We are in business, boys. So from here, we want to create that account, right? So the first thing I want to get is this. So maybe this will make more sense. For when we buy a ticket, what context do we need? Well, we should know what the lottery is, right? If we need to pass in the lottery ID, we should know the ticket, right? So that means we have to create an account. We should know the buyer, right? Buyer, and this one's always here, but we need the pub system program. Okay, so this is all the context we need. We need to get all of the context, and the first way to get the lottery is to write this account thing again. And my question to you guys is, do we need to initialize it? No, we just have to say it's mutable. We just need it to be mutable because there could be different lotteries that we're getting. How do we determine and calculate what lottery we need? Well, let's pass in the same seeds to get that address. So we need lottery seed, I believe, that as bytes. Okay, comma. And what else do we use as a seed, guys? It's gonna be and lottery underscore ID dot to underscore le bytes parentheses. Cool. So that's it for seeds. Don't forget this bump here, and that's it for lottery. Right, we just need to put the type lottery. What is it expecting? It's an account. What kind of account is lottery? It's a lottery account. All right, so now we have access. Well, we're giving it context within by ticket. Okay, so now the important part, the ticket itself, right? Is there an account that we set up for a ticket? Like, does our code know what a ticket looks like? No. So what do we have to do? we have to initialize it. So let's do account and say parentheses here and say init to initialize it. The payer, right? We usually put payer here, but we actually can put the buyer, right? And again, if this confuses you, you can put it as authority, but when you see me use this variable later on, it'll make more sense. It's just for naming purposes. Same thing though. Buyer is gonna be signer. So we can do that now. So we should say buyer is the signer, right? Whoever signs for it, that's the buyer. The payer to pay for the space is the buyer. Space, all right, I'll tell you right now, it's gonna be 4 plus 4 plus 32 plus 8. And again, you don't have to put the 8 at the end. I just want you to know this is something called the account discriminator. Cool. And now for the seeds, right? This is the fun part. Seeds is equal to, it's gonna be a couple things, right? So we're leveling up. Before, to get the lottery, we need 2 seeds. But for the ticket, we're actually gonna put 3. All right, so the first one is the ticket seed variable, which we need to create later as bytes. Next thing is we should put the lottery key, right, dot as ref. And I want you to keep in mind what seeds do we use for each account, right? So this takes 2, this takes 3. What kind of things does it take in, right? And then we also need to do and lottery dot last ticket ID, right? So very similar to how we got the lottery ID as the current lottery ID as part of the seed, we need the last ticket ID, right? So if I scroll up here, just like how our master keeps track of the last ID or the last lottery, the lottery keeps track of the last ticket ID, right? So is it this ticket number 0? Is this ticket number 1? It's number 2, right? We help determine that by passing it right here. And again, it's last ticket ID plus 1, right? So the first ticket ID is going to be 1, all right? So after that, we can play dot to underscore LE bytes. Okay, and you could put a comma here, but not necessary because it's the last one. All right, so make sure you spell that all correctly. Don't forget to put a comma after the space and a comma after this and say bump, right? So we add the mandatory bump. Next, for the ticket, right? What kind of type is the ticket? It's an account. We say info, and what account is this going to hold? It's going to hold the ticket one, but we don't have that yet, so we need to make it. So I'm gonna put comma here, and for the system program, we're just gonna put program. Oops, this is pretty standard. Program info system. Okay, cool. So there's that. That's the by ticket struct. Let's make the account now. So we can say hashtag account. And then under here we say pub struct ticket, boom. And again, if this is not the right color, we are missing something. What are we missing? Buyer. Is this? Signer. Oh, I forgot. This one needs to be mutable. Account mute. Oops. Okay, so that's one thing. What else? Missing something else here. Signer, system program, that's fine. Ticket. Bump is good. This is good. Oh, comma here. Hey, we're good. Okay, yeah. Don't forget your commas. So, ticket. What is the properties of a ticket, right? What do we need? We need what's the ID, and who has authority over this ticket. So let's do pub ID u32. the authority. And last but not least, we want to put pub lottery ID, right? Again, this is kind of unnecessary, but when we fetch tickets from the front end, it'll be a lot easier because we can say like, oh, give me all the tickets from lottery number 2. Otherwise, we'd have to go to each lottery and find out, okay, what are the tickets inside that lottery, right? It's easier to be like, okay, this ticket is with lottery number 2, lottery number 1, right? This is going to be U32. Amazing. Cool. So we got the account. We have the struct, the context for buy tickets. And now let's just quickly make the variable pubconst ticket seed type a referenced string and ticket. Cool. All right, so now that should exist, and I can't pass build yet because we didn't write any logic for buy ticket, right? So how does buy ticket work? All right, so what is buying a ticket? It's exactly what it sounds like, right? We're purchasing a ticket for the lottery, right? But what should happen is when we buy a ticket, we create a ticket account and pay, right, the lottery with the ticket price, right? So if the ticket price is 1 sol, where does that 1 sol go to that I spent this ticket on? All right, it goes to that lottery that I pass in, okay? So when we buy a ticket, we create a ticket account and pay the lottery with the ticket price, which is our case 1 sol. Got that? So how do we do all that? Well, the first thing we're going to need to do is set up the variables. So let's say let lottery is equal to and mute, because we need to do this. It's going to be a different lottery every time I run this function. It's not going to be the same one. And we also need to assign some variables to it. So we say and mute ctx.accounts.lottery, right? Do you guys understand where I'm getting this from? I'm getting this from the context because the accounts at buy ticket are a lottery account, there's a ticket account, there's a buyer, and a system program. So when I say .accounts, I have access to all 4 of those things, saving that variable in not lotter and let lottery, right? So we can say let ticket is equal to and mute ctx.counts. And I know, I see it, good catch, and mute dot ticket, right? And again, you don't have to set up these variables, but I want to, otherwise you have to write ctx.accounts.lottery.lastid, ctx.accounts.ticket, blah, 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 right? We want to make the variables so we can shorten it. So we can say equals and ctx.account.buyer, right? Oh, .accounts, sorry. Amazing. So the buyer is in this variable, ticket, lottery, we're good. So now let's check, right? So let's transfer sol to lottery PDA. Okay, so to transfer our sol to the lottery account, right? Remember that's last part of the pseudocode. We want to invoke a function, right? So right, invoke parentheses, and to transfer you just say and transfer. Okay, so once you do and transfer, right, you can put parentheses here. I'm gonna hit enter so that we can list them out. But basically, you want to write who you want to send money from. So where is the Solana coming from? It's coming from the lottery, the ticket, or the buyer. The buyer, exactly. So we have that variable. So if we say and buyer.key, right, the buyer at this key, comma, we want to send it to the ticket or the lottery. The lottery, right? So that we can add to the pot. So and lottery dot to account, to account underscore info, and we say ctx dot accounts, right? Oops, not that one. Sorry. And lottery dot key. This is actually later. So yeah, basically from, to, and how much. This last part is how much do they send. Well, we know how much each ticket costs, and where do we save how much each ticket costs, we save it in the lottery by saying lottery.ticket price, which should be, we set it up to 1 Solana. All right. So we got key buyer, which is from to how much. Okay, pretty simple so far. And after this closing parentheses, put a comma, right? This first one, you can see it by the matching one. Hit enter and just say and array, right? Because this is the information of each one. So we can say, we can say buyer dot to, account underscore info, comma, comma, we can say lottery dot to account underscore info. We can say CTX, this is what I was doing before, accounts dot system program dot to underscore account underscore info. Cool. So all of this is part of the invoke function. The only thing you'll need to do after this is, after the square bracket, put a comma. And after this closing parenthesis, you can put a question mark here, semicolon, and we should be good to go, right? Because this closing curly bracket is still our function. There's some other things we need to write here, like lottery dot last ticket ID, right? After we buy a ticket, we should also increment the last ticket ID, right? So that we don't have the same ticket with the same ID. So how do we increment this variable? Plus equals 1. Okay. So we can say the ticket. Oh yeah, we need to set these values, right? What is the ID of the ticket I just bought? Well, it's going to be equal to lottery dot last ticket ID. Okay. Basically, if the last ticket ID is 0, this ticket I just bought is going to be ticket ID 1, right? And that makes sense. We also need ticket.lottery ID. Like, what lottery did we buy this ticket at? We bought it at lottery underscore ID. It should be the same. Okay, and then we need ticket.authority, right? If I'm getting any errors, it's probably spelling. So buyer.key, right? Who's the authority? Should be same as the buyer, which makes sense. And we can add some nice messages here, right? So we could say that the ticket ID, and how can we do like a template literal technically here? We can say ticket ID. All right, again, this variable or whatever value this is will go here and it'll remove the square brackets. Also message, you can say quotes, the ticket authority, who has authority over this ticket. It should be the now ticket authority. So colon this ticket, comma, ticket.authority. And then, okay. There is one more thing that we should add before we completely finish this function, and it's just basically some error handling. So if you think about it, right, we create a lottery, we buy a ticket, we pick a winner, right, and then we claim the prize, right? But if we're still on lottery number 3, there's already a winner. Should we be able to enter and buy another ticket? No, it's kind of like a scam. There's already a winner. We shouldn't buy tickets at that lottery, right? So we can add that error handling in here, right, with some sort of if statement, okay? Another cool thing we could do is make another file that has our error messages, right? Which is really cool in Rust. So you could say error.rs, and that will be where we write all our error messages. And once again, you don't have to make an error file. You can actually just put all of it in the lib, but just for organization purposes, right, we can do something like this. So we can say anchor lang prelude error underscore code, right? So quiz time, what did we just import here? We went into anchor lang, we went into prelude, we got error code from prelude, and now we can say error code, and you could say pub enum, right, lottery error, and we can say hashtag message winner already exists, right? And then we can say underneath that macro, we could say winner already exists. This is the type of error that we get, and this is the message that will come out of that error. Okay, it's enum because we can allow multiple errors here. Okay, and since we're here, let's write out all the possible errors. Again, to make a message, you say hashtag message. Another one that we need to think about is if I want to pick a winner but nobody bought any tickets, that shouldn't be possible, right? How can we claim a winner if nobody added to the pot or if nobody bought a ticket? So you can say something like can't choose a winner when there are no tickets, and you can call that type no tickets, right? So when I'm going back to this code, I can call literally winner does not exist, already exist, or no tickets. I can just write this and it'll know which error message to send. Okay, another one is this message when there's a winner not chosen, right? So we can say winner has not been chosen, period. And from there, I'll just add the periods here. Period, period. Okay, and then we call that winner not chosen. Right, is this making sense so far? Another possible error that we might want to use is message. If there's an invalid winner, like for whatever reason the ticket was invalid, right? They somehow got a ticket that doesn't make any sense. We can say invalid winner and call it invalid winner. Okay, and I can only think of one more. If you guys have any more, feel free to add it. All right, the prize has already been claimed. Right? Can you guess what kind of error this is? It's basically somebody has claimed the prize, right? And someone's trying to claim the prize again, which shouldn't happen, right? Which should say already closed. Cool. And that's how you make error. Yeah, so that's how you make all the errors. And I think this should be already closed, already claimed. I like how that sounds better. Okay, so again, we made an error file. We can import this by saying error :::::. We can say mod error, and now, right, this brings it into this scope. As you remember, use super brings everything in this scope into the program, right? So I don't have to go into that folder. So let's go back to here and let's do one of our checks. So I'll put this at the top here. If, right, there's still if statements here, but it's different. If you say if lottery dot winner ID, and just in case you didn't know, I'm trying to do the winner already exists error. All right, so how can we tell if a winner already exists? Well, let's think back to the lottery struct, right? We have this winner ID, and the way to look at it is like option basically means the winner ID can be two things. It can be like some, and there's like something in here, or it can be none, right? We kind of saw this when we saw the lottery account, and the winner ID is null, right? So that means it's not some. And when I say T here, it means a value, right? So there's an ID here, whatever it is. Okay, so let me erase this because we don't need that. So what I'm saying is, if lottery.winner ID dot is sum, right? That means it's not empty. Like there's something in here. There's a winner, right? So if winner, return error, and then you can say lottery error, right? Why am I saying lottery error? Because that's the type right here. That's the enum. Lottery error is winner already exists. All right, does that all come together now? If there is a winner, return the error. And what kind of error are we returning? That the winner already exists. It would print out this message, winner already exists. Pretty cool, right? So when you're making your own app, think about that structure and what you need from that error. Right? What kind of error do you want to display here? Okay, I think we can buy a ticket now. So let's see if we can build. I'm guessing there's probably going to be some spelling errors. Yep. lottery ticket prize. Anything else? Lottery ticket prize. What's the first thing? Okay, there's a lot to go off. This pair specified does not exist. Okay, so this is the first thing, 158. Let's take a look. Okay, so it's something wrong with the payer. The payer is the buyer. The buyer should be the singer. It should be the signer. Spelled this wrong. Signer. Okay. Let's see what we get now. And let's hit build. There's probably some more things. Look for the next building. Here. Expected function macro error. Return error, not a function. Oh, okay. So there's something with our check. So it tells me we should go up here. Return error. Return sum. Return. Oh, it should be exclamation point. Same way we have message exclamation point. That should be the same thing. And I think we might need exclamation point here. Let's see. Let me just test it first. So let's just clear this out. Go back to here, build. A lot of errors. Where is our, that's the first building. Second building, third building. Okay, unused imports, that's fine. Ooh, right here, no field ticket price on type mute anchor lang. Unknown field. Oh, I did it again. It should be ticket price, not ticket price. So line 59, ticket price. Okay. Let's see, does it like that? Build. Taking a while. Build successful. Okay, let's go. So again, if your code has errors, that's not necessarily a bad thing. It's just about understanding why it works, which a lot of the time I don't understand why it works, but luckily we're able to figure it out, right? So every time I put prize, it should be price. Another thing that I realized, error should have an exclamation point here. Cool. So build successful. Let's run it one more time to make sure. Build. Boom. Okay. So build successful, that means we're good. Again, warnings are okay. Cool. So what do we do after we finish building? We upgrade. Again, upgrade's gonna take a couple seconds, but I'll be back when it's done. Cool. All right. So deployment successful, right? If you go to tests, we have buy ticket now. So let's just review what we have. We should have a master initialized. We should have one lottery active, right? There's no winner. There's last ticket ID is 0, which means how many tickets there are? 0. There's no winner, false, which means there's no winner, or like I just said. And how many tickets do we have? Empty. All right, so let's buy a ticket then. All right, so how do we buy a ticket? Actually, we need this one. We open this up. We need to pass an argument, and we got to pass in all of the accounts. So what is the lottery ID, right? What lottery are we buying a ticket for? That's what this is saying. Well, our ID is 1. So we should just be able to put 1 here, and we're good to go. So that's it for arguments. But all about for accounts, our context, right? Do we have a lottery that we want to put here? Do I need to generate a new one from seed? No, we already have a lottery. We just need the public key of that lottery. So does it have a public key? Right, I fetch it right there. The 9C for me, that's the lottery public key. Cool, paste that. Ticket. All right, let's pause on ticket. But buyer, who's buying this ticket? Me. So then you should say my address, system program's good. Now for the ticket, right? How do we generate a public key for the ticket? The first question I ask myself is, do we have a ticket already? Nope, we do not. So we need to generate it from seed, right? So the first thing that we write for ticket seed is just ticket, I believe. You could double check that in your constants, ticket. Then we need a lottery key dot as ref. That should be public key, right? when it says lottery.key, that's just the lottery's public key, which we have right here actually. So copy that, paste it, right? Mine is 9C, yours will be something different here. Oops. And how many seeds we need? We need one more, right? We need the lottery dot last ticket ID. So what was the type of last ticket ID? Let's see, we scroll up, last ticket ID is U32. So we can add that as U32. And then let's scroll down. It's gonna be the last ticket ID plus 1. So we can take a look at that. So the last ticket ID is 0. What's 0 plus 1? 1. You hit generate, and that should be our public key that we get. That's the account public key. We hit test, hope for the best, and we bought a ticket. Let's go. So that means we spent some Solana, right? I've already forgot how much tickets we bought, but there we go. Awesome. So let's see how many tickets we have. We have 1 ticket with the ID of 1. What lottery did we buy it for? Lottery ID number 1. Okay, so now if I fetch this, what should be the last ticket ID? 1. There we go. And let me show you this example by buying another ticket. All right, so for arguments, right, what should be the lottery ID? 1. What should be the lottery? This. Who is the buyer? Still me. So what does that mean in real life? I'm buying 2 tickets, right? For a ticket, should it be the same public key? It shouldn't, right? So we need to generate this from seed again. The cool part is you'll see the difference, right? So to generate a ticket public key from seed, you just have to put in the same seed. So you say ticket, and then you say pub key, which is the same. But here's where the magic happens. On the third one, where you expect the U32, last time we put 1, right? Because we got the last ticket ID plus 1. You don't want to put 1 or else we're going to get the same public key. We're going to get this AY. We want something different, otherwise that already exists, right? So we need to figure out the last ticket ID, which is 1, and add 1 to it, right? So we add 1 to it, 1 plus 1, 2, right? We hit generate, and now it's C and I. And just to make sure, I have 4.7 SOL. Let's hit test. Let's go, I have 3 SOL, right? So that means I took my Solana from this wallet and put it into this lottery, right? So if I ask you what is the total pot right now, you can't see it from here, but the total pot is 2 SOL, which means if I pick a winner, they're gonna get 2 SOL, right? We just successfully transferred it to this account. There's a concept called escrow, right? This is essentially an escrow, okay? But don't worry too much if you don't understand it. So we have 2 tickets, right? We can see that here. If I fetch all the tickets, there's 2. You can see what ID. You can see who bought tickets by the authority, right? 60, 60, so 2. I bought 2, right? Cool. So let's go ahead and make the next function. All right, so we have init master, create lottery, and now what should we do? We should pick a winner. Okay, so to get started with that next function, we can bring this over here. Scroll up to the top, and I'm gonna teach you guys a shortcut I showed you guys earlier, but you can say FN and click this right here. You can create a function. And the cool part is the important stuff is highlighted for you. So let's say I press backspace, I press pick winner, and if I press tab, I can edit the context. And the context, you guys should know, should be pick winner, right? So what the hell is pick winner? This is kind of like the meat of the function, right? Basically, you want to, let's say, select a random ticket as a winner, right? And set the winner ID to that winner. Okay, so the cool thing about this shortcut, it already sets up our OK, it sets up our context, and we just have to fill in the blank really because it's pretty repetitive. So let's go here and let's create that context for declaring a winner. So what I'll do here is type in hashtag derive accounts. All right, we can say hashtag instruction, because there's something I do want to put in here. We want to put lottery ID, right? Because we need to know what lottery are we picking the winner from. Is it the first one, the second one, the only one, right? So we can say space U32, and underneath is where we write the struct. So you could say S or CS for create struct. Click this, boom. And then again, it highlights what we need to edit. So we can say the struct is pick winner, and of course put your info in here. Okay, cool. So we have the struct set up. Let's set about the account, mute account, oops, like so. Yep, it's gonna be mutable. Hit enter, because it's gonna be a couple other things. Because the reason I want to do this is not this right here. It's gonna be for the lottery, right? Because like I said, we need to get the context that we need is the lottery itself. So we want to make sure that's mutable because it can be many different lotteries. We need to tell them what seeds to get the right public key, which will be lottery seed dot as bytes, comma, self-reference, and lottery ID dot to underscore le underscore bytes, parentheses, comma, and we don't forget bump, and we can do a has one equals authority. Okay, because only one account can pick the winner, right? And the person that can pick the winner is the one who created the lottery. Otherwise, if let's say there's Mega Millions jackpot, right? If I'm picking the winner, right? I shouldn't be the one to pick the winner if I didn't make the Mega Millions jackpot. All right, cool. So then we can say enter pub authority is just the signer, who's ever signing. All right, info. Perfect. Put a comma here, and comma here. And that should be it, right? That's actually it for picking a winner. And I would ask you guys, do we have to make any new accounts? Nope, we just want the lottery account. Cool, so this should be the struct. I'm trying to think. Yeah, this is it for the struct. The difficult part about this function is gonna be the logic of pick a winner, right? Because yes, the pseudocode is select the random ticket as a winner and set the winner ID as the winner. The issue here is a random ticket, right? Because in Solana, there's no true random solution, but there is like a pseudo random solution, like pick a pseudo random winner, right? And you don't have to fully understand how to do it, but if you want to know how to get a pseudo random number in Solana, this would be the way. Okay, so I think oh wait, hold on. Sorry about that, camera died, but we're back. So as I was saying, I think the best way to show you guys how this pseudo random number works is let's build out the whole thing and let me talk about it. Okay, so the first thing you need to write is a variable called let clock, and let's get the clock. And again, this, if you're wondering where clock is from, we're finally using all these imports over here, right? The clock, the hash, we used invoke already, we use transfer, but we need the clock and the hash. So the first thing we need is the clock. To get the clock, we say clock, we say clock colon get right here, okay? And then put this question mark and say semicolon. And then from there, we also want to make a variable that's going to hold our random number. So the random number will be called let pseudo random number, because again, Solana is what we call deterministic. So it will usually know the answer before the transaction goes through. And that's why it's hard to get a random number. Another way to get a random number is if you have to set up some sort of oracle, but that is way above my knowledge. So this is a way to do it. So we've set a variable here, and let's just put parentheses, because within these parentheses, we want to write something. And bear with me, because this is, again, I'm even still trying to wrap my hand around this, but from what I understand, we want to make a number, right? We want to make a big number, which is why we say U64 here, right? And we can generate a big number from bytes. So we say from le underscore bytes, okay? And again, this is a function in itself, and to generate a number from bytes, right, to generate a U64 big number, we need to pass something in here. So I'm gonna hit enter, and what we want to pass in is this. We will say less than greater than array, and it's not an array, it's just square brackets. So U8 8, and you say colon colon try from parentheses, and again I'll break it down after I write it all out, and hash. Okay, again, so we're using that hash function from the top over there that we imported. All right, this hash, okay, and what we want to do is say in hash parentheses, because that's a function. All right, we're going to generate a hash from this and clock, right, dot Unix timestamp dot tobe underscore bytes parentheses. Okay, with me so far? Cool, because the next thing after this is going to be dot to bytes, right, and make sure it's out of this parenthesis right here, dot to bytes parenthesis dot 8 parenthesis dot unwrap. Actually, I could just write that here, dot unwrap. Okay, and then you put a comma, right, and after that comma there should be one parenthesis here. You can hit enter right there, and you can say times clock that slot, right, and in the next line, right, just to organize this information, oops, and slot, you can say %U32 max as U64, and you can say in between these two parentheses here as wait, did I do this right? %U32 max as 32. Okay. Let me see. So this opening has a closing. This one has a closing. This one has a closing. This one has a closing. And this one closes. So yeah, there's an extra one right here. Semicolon. And yeah. Cool. All right, so yeah, I know this was a lot. If you didn't click off the video, congratulations, you're a trooper, because this definitely was a doozy, right? But to break it down in simplest terms, like I mentioned before, we want to create a big number, right? And I represent this big number by saying U64. So I want to make a big number. To make this big number, I'm calling this function called bytes from LE bytes, right? And what this takes in is bytes. So in between this parenthesis and this parenthesis, we need to get bytes, right? So you can assume that this whole thing here is giving us bytes, right? Here's the thing though. If this gives us bytes, what the hell is this thing I'm highlighting? Well, to tell you, right, from here, we're getting a try from, right? Don't worry about that yet, which is another function that's calling a hash function. So again, big number, we want a big number from bytes, and from those bytes, we're gonna call the hash, and then we're gonna get the clock Unix timestamp, right? So what is the clock Unix timestamp? It's basically what time is it right now. It could be like 12, it could be 1922, right? Whatever that is, that number, and turn that into bytes. Okay, because the hash function, this whole thing I'm highlighting, right, it wants bytes within here. So take the clock, take the time, turn it to bytes, and then let me highlight a new thing right here. This will return a hash, right? So it generates a random, a hash from the time. And what makes this already kind of random is the time, right? Because the way time works, right, it'll be a different point in time of day depending on when you run this pick winner, right? And from there, it will generate a hash for you. And again, to make this function work, we had to turn that back into bytes. Okay, so that's this whole thing. So so we want a big number. So we have to turn it into bytes first. We take the time, turn that into a hash, which then we turn into bytes, right? And then from there, you're gonna see an unwrap, right? Because the reason why there's unwrap here is because this try from can fail, but it will never fail, so you don't have to worry about it. But we do just want to put an unwrap here. And last but not least, we need to multiply the time slot, the clock dot slot, right? So not only are we getting a big number from here, right? We're also gonna multiply that to get that big number. So again, it's not truly random. Technically, there's a chance that it won't be random, but it's what we call pseudo-random, okay? And then from there, we're casting it as a 32, it's going to be U32, there you go, as U32, okay? So that should give us a pseudo-random number, okay? And if I did this right, we want to say let winner ID, right? It's a variable, set this equal to parentheses, pseudo random number, that variable, whatever that random number is, and we say modulus lottery, right? Where are we getting lottery from? Right, from our context, right? We set it up all the way down here in pick winner. We have the lottery, so let's get that context, right? So I can't just say lottery just yet. It's gonna be undefined, but let's define it here. Let lottery is equal to and mute ctx.accounts.lottery. So we have access to that now. So I can say lottery.last ticket ID, right? So basically, this is how many tickets there are. This could be 5, this could be 2, this could be 1. And for example's sake, how much tickets do we have right now? So we have 2, okay? So the way this is shaping up to be is we take the random number, we do modulus 2, and we can't forget we need to do a +1 here, right? Because it could be 0. All right, so basically pick a random number between how many tickets we have. So if it's if it's 1 to 7, pick a number from 1 to 7. That's the winning last ticket ID. So it could be ticket number 1 or ticket number 2 in our case. Okay, so that's how it should all work, right? So once it selects that, it's going to store it in this winner ID. That's the winning ticket, right? And then from there we can say the lottery, lottery. Oh, it's weird. Why is this doing this? Dot winner underscore ID is equal to sum winner underscore ID, right? So remember how in the lottery struct we had winner ID as an option. It could be either what, guys? It could be sum with a value inside or none, right? Or as you saw as null. Right here, we're making it from null to something, and that something is the winner ID. That's the simplest way to look at it. And then from there, let's make a nice message here that the winner ID is winner underscore ID, and this should be a comma so that it'll take whatever this is and write that message here, and then semicolon. And yeah, that should be it. So again, this could fail because I might have wrote this wrong. It is a lot of code, so let me just double check it. Okay, pseudo random number U8 2 B bytes 2. Oh, I already see an error. It should be 2 underscore bytes, so make sure it does that. I'm gonna hit enter here, so it's still gonna work because I didn't put a semicolon. It's just so that it doesn't wrap around that screen. And let me see, clock slot. Okay, so that looks good. Pause this video and make sure it looks exactly like this, because there could be a chance you're missing a comma, semicolon, spelled something wrong. Right, if there's any errors, it'd probably be around here. Cool. Now I'm double checking this line. Pseudo, spelled pseudo wrong. EU. All right, that's how I spelled it here. EU, yep. Okay, I'm pretty good with this, so we can pick a winner. Okay, and that's it. So let's go ahead and build. Let's see if anything else comes up. Of course, can't infer struct. So let's see at the very top, because that's usually where the error begins. Unresolved import for a client's client account signer. Okay, 193. Taking a look at this, I should put pub struct here. I don't know if that'll fix it, but we'll see. Nope, can't infer type. This looks good. Pub lottery, count lottery, pub authority, singer again. Forgot signer. Now we hit build. Hey, build successful. Okay, so we got a build. It's successful. And now what do? We hit upgrade. So give this a couple minutes and we'll be right back. All right, so it was successfully deployed again and upgraded. And now we have a pick a winner function. So let's run it. All right, so let's see. Just to recap, we do have one lottery that's ongoing, right? Because it's not claimed. There's no winner yet, right? And we have 2 tickets, right? So I bought 2 tickets. So out of these 2 tickets, who's gonna win? At the end of the day, it's gonna be me, right? Because I bought both of these tickets. But which ticket's gonna win, 1 or 2? I don't know. All right, we can do that by picking a winner. And to pick a winner, let's see. I don't think we have any arguments, I believe, right? We do need one more thing. So we need a lottery ID. So we gotta pass that in. So where is buy ticket, pick winner? Yep, so over here we put comma. Let's put underscore lottery ID, right? The reason we put underscore is because we don't actually use it. We just need to pass it in here, right? Because it's gonna go into our context. So let's go build. Build successful, type upgrade, and now we're good, right? We gotta make sure to pass this because we also take it in our struct right here, lottery ID, because we need to know which lottery are you picking the winner for, right? So it's almost done. Man, I really need to win this lottery because I'm running out of soul here. Cool, so again, we upgraded it. So now when I pick a winner, we can pass in a lottery ID as an argument. So what is the lottery ID? I already know it's gonna be 1. Right, but there could be multiple lotteries ongoing. But lottery ID is 1. The accounts should be pretty simple. What lottery account are we passing in? There's only 1. So put this public key, mine is 9C. Yours could be something different. And for authority, you put my address because I'm the one who created this lottery. I'm the one that has authority. And let's pick a winner. Boom, pick winner, passed. So there is a winner here. And remember how it says the winner ID is null? When we fetch this, it should be something different. 2. So what that tells me is that ticket number 2 is the winner, right? But notice something. Where's my money, right? I should win the 2 Solana that I paid, right? Well, I don't have any. So we need to make that function, which is picking a winner. Okay, so we successfully picked the winner, right? Now for the final function that we need to make, it should be, as you know, claim the prize. And claim prize is exactly what it sounds like. All the money is in this lottery account, and we want to take that money from the lottery account, our third-party account, and put it into our wallet. So that is what the pick winner is going, claim prize is going to do. So I'm going to go over here, and we can say fn, and we can hit create, and we can say claim prize tab. Claim prize, and I'm going to move a little bit faster on this, right? And then put comma. It's also going to take in lottery ID, and we're not going to use it in this function, so we need to put underscore. So it's going to expect a type of U32. It also will need to know what ticket won, so we need to pass that in. So put underscore ticket ID U32. Okay, and then from there we can say let lottery is equal to and mute. Oh, actually we don't want to do this yet because it doesn't make sense yet, but it will in a second. All right, so that kind of gave it away. In our context, we need access to the lottery. We need access to the completed ticket word, and we need to basically determine who the winner, grab the winner, right? So let's scroll down all the way to the bottom. Okay, and let's start creating our structs. So to get started, you guys should know the drill by now. We do this macro of derive accounts. You say hashtag instruction, and you saw how many things are we passing in here. We're passing 2, the lottery ID, which is expecting a type of U32, and after the 32 put a comma and say ticket underscore ID and say U32. Right, this is a lot of code, right? So that's why we're not focusing too much on the front end. We're focusing on the Web3 part of this. So, and again, if you ever want to learn how to make the front end for my beginners out there, comment down below saying that you want the full complete tutorial, right? But this is more so if you want to learn Web3 with me. So let's say the struct is claim prize. We say info, put the curly braces, and this is our scope. Okay, it looks pretty good so far. What we want to do here is we want to get the lottery, right? So how do we get this? Well, you should just press tab and say hashtag account. We want it to be mutable because we could get multiple. We could be claiming the prize of several lotteries, right? So it could be seeds, not just one. And what are the seeds that we usually get for lottery? Right? If you get confused, you can look above, but I'll tell you right now, it's lottery seed that has bytes, comma, and it also takes in the lottery ID dot 2 le underscore bytes. Okay, and of course bump, and that is the lottery. And what is the type of lottery? Lottery is going to be an account, so let's write that. And what is going to be the type of account? It's going to be lottery, which we set up, so we don't need to create it, which is why we don't say init here. Okay, cool. We also need the ticket, so I'm gonna put a comma here. And how do we get the ticket? Right, so to get the ticket, we say hashtag account again, and we say seeds is equal to, right, this is different, right? I didn't say mute here. I'm putting my seeds already, and I'm formatting like this because there's a lot of seeds. We want the ticket seed dot as bytes. And what else do we want, guys? We want lottery dot key dot as ref, and we also last seed was the ticket ID, I believe, ticket ID. And to do this, we need to do dot 2 le bytes. Nice. So this should give us the PDA of our ticket. We hit comma, we hit bump, and there should be one authority for this one. So we say has one equals authority. Okay, so ticket is good. You can say account info, comma ticket, comma, and you can say hashtag account mute because it can be a different person, a different authority. I mean, pub authority is the signer. I almost put singer again. Signer info, and of course the last part was the system program, which is going to be the same. So program info, comma system. Okay, we breathing? We live? Good. Yeah, just give me a nod if you're still here. Good. I have no way of confirming that, but I'm glad that you guys nodded. So we have the struct for claim prize. Yep, claim prize. And let me ask you, do I need to make any accounts? Lottery, ticket. Nope, we have those exist. Cool. So that's the struct. Now I can go back up and actually claim the prize. Okay, so let's set up our variables again. So the first one is the lottery. How do we get this? We say and mute ctx.accounts.lottery, because this we can claim the prize of different lotteries, right? We can get the ticket and say and ctx.accounts.ticket. We can say let winner is equal to and ctx.accounts.authority. And there we go. All right, so what do we need to do first is we need to, I'll say validate the winner ID, right? So to validate, we can say match. So we can say match lottery.winner_ID and say curly brackets here. And we can say, remember how it's a sum? We can say sum winner ID and equals arrow, like so. And we can say if winner ID does not equal, whoa, I didn't even know it does that. Hashtag exclamation point equals, does not equal ticket.id, then we should throw an error. So we say return error, and we say, oh, don't forget the exclamation point, and we say lottery error : invalid winner. So for whatever reason, the winning ticket doesn't match the ticket that we put in, we can say invalid winner. Okay, curly brackets, and then we can say, so sum can either be something or none, right? So if it is none, right, you can return another error, which probably won't happen often. So it says lottery error is winner not chosen, right? This is if you try to claim a prize, right, but the winner hasn't been picked yet, which in our front end, you'll never see that happen. But in the case you did, you'd run into this. Cool. And another check that we need to do is if the lottery.claimed, right, that if that is true, if the prize was already claimed, it should also return an error, which is the lottery error that we created already closed, right? Somebody already claimed it, right? So you shouldn't be able to press that button again. So this is just a back-end check, back-end check, back-end check. Cool. For now, for the actual transfer, it's going to be a little bit different than how we transferred it before. So we say transfer the prize from the lottery account, or lottery PDA, same thing, to the winner. So how do we do this? So as I was saying, to get started, we say let prize here is equal to lottery. Yeah, we have lottery, right? Yep, we do, lottery. Let lottery. And again, because we don't put a semicolon, this is technically saying lottery.ticket price. Okay. So we take so to get the prize from the lottery PDA to the winner, we have to first get the total pot, right? So if again, we had 2 SOL, to get this 1,000 SOL, we got to calculate it first. So to get that, we say .ticket price .checked multiply, right? Basically it's going to multiply lottery dot last underscore ticket underscore ID dot into, right? And then we just add a dot unwrap. All right, so this should calculate what the prize is. So basically, to sum it up, we take the cost of each ticket, multiply that by how many tickets there are, and then unwrap it. So let's say each ticket was worth 5 Solana. If we bought 2 tickets, the total prize money would be 10. All right, so do that quick calculation, and then afterwards, we want to do a ***. And again, this is double dereferencing, but don't worry too much about that. I suggest like you look into double dereferencing, but the main thing is write ** lottery.toAccount, right? This is so that we can properly access that information. That's the right, we need to do this first, because we can't just write lottery.toAccount. So lottery.toAccount info.try borrow mute lamports, right? Lamports. Okay, and then we say minus equals prize. Okay, so basically try to get the lottery info, right? See how many lamports it is and subtract the prize from that. So let's say the total pot is 10 sol, right? Basically take 10 sol from the lottery tab, right? Take the total prize money from a lottery account. Okay, so we successfully took the prize away from the lottery, so removing the funds from the lottery PDA, and now we can say star winner dot to account, right? Because we have a winner, I believe, right? Winner is the authority, right? So yeah, so whoever is the winning wallet address, they should be able to see the claim prize button, right? So basically, if I were to show you visually, I pick a winner. You only see this button if you have the matching ticket, if you are the owner of that winning ticket. Let's say I click pick winner and I wasn't the winner, like it wasn't my ticket, I wouldn't see claim prize. I would just see enter, pick winner, and create lottery again. Make sense? So that's who the winner is. It's exactly what it sounds like. So winner.toAccount info parentheses try borrow, right? Mute lamports again, question mark, and essentially this means plus equals prize, right? So basically subtract that prize money from the lottery and add that prize money to the winner, right? Add that same amount to the winner. Okay, cool. And then the last thing we need to do is lottery.claimed, right? By default, this is false, but now that we gave money to the winner, we can say that that lottery is claimed, set that to true. Okay, so then we can say MSG, exclamation point, right, and say quotes, curly bracket here, claimed, right? It's kind of like a template literal, lamports from lottery ID with ticket ID this. All right, and it's gonna have a lot of stuff. That first curly bracket is gonna be the winner.key, what key won, what address won. The second curly bracket will be the prize, how much they won. Lottery.id will be which lottery is the winner from. Is it lottery number 1, number 2, right? And what is the winning ticket ID? Okay, semicolon here. And we did a bunch of errors, and I'm just realizing we should do some error checks up here at the top with the pick winner. All right, so let's do some checks. Lottery equals that. We can say if lottery, and this is again, I went up to pick winner. I wanted to do some error handling here as well. So lottery.winner underscore ID dot is sum. All right, we want to return error, lottery error, right? Because if there is something already in the winner ID, then we know that the winner already exists. Like that's if I tried to click pick winner, winner's already a winner. So that's that case. There's also the case that, oops, we don't need the parentheses. If lottery dot last ticket ID is equal to 0, we can return another error, which is going to be a lottery error that we set up, and the specific type is no tickets. So basically, if I tried to pick a winner and nobody entered in my lottery, right, they shouldn't be able to pick a winner, so we should get this error. I will say though, for the front end, we have some checks so you wouldn't even see pick a winner if nobody entered, I believe. Okay, so those are the checks for that. That was just my quick tangent. But for claim prize, This looks good to me. So moment of truth. Let's see if I wrote singer again. Let's hit build. Yes. Okay. Use crate. Error. Expected 122. 122. Invalid winner. I missed something here? Oh, I put a comma instead of a semicolon. Okay, let's hit build again. Okay. This is good. Take the total from found in the scope. Prize is not found in the scope. What? It's right here. Let prize. Let me just take out these comments. I don't think it's gonna fix it, but let's just take these comments out. Let prize. It's strange. It should be in the scope. Like it's right here, but I'm guessing it's because a semicolon somewhere. Oh, right here. So after the dot unwrap, can't forget the semicolon. And bam, build successful. Like, isn't it crazy how like one semicolon like just ruins your entire code? The reason why it said prize is not found in the scope is because I say let prize here, and the code line technically doesn't end until this line right here. All right, so it's saying that this whole thing I'm highlighting is one line. If I put a semicolon here, it makes all the difference. So if I build successful, hit upgrade, and now I should be able to claim my prize once this is done. Okay, upgrade successful. And again, I'm still have 3 soul here, but I haven't claimed my prize yet. So let's go ahead and do that. So to claim a prize, I have to say the lottery ID, which I know is 1. And if you're not sure what lottery ID, click fetch all, look right here. I'll also fetch the ticket. I believe the winning ticket was number 2, right? Winning ID 2. So ticket ID should be number 2. And we can do the lottery, which we have right here. Mine's 9C, yours might be different. Cool, and then the address of the ticket. Oops, did it disappear? Yep, the address of the ticket, which is number 2, so it should be the CN. And again, if I were to put anything different than what I'm doing now, it would fail. My authority is me. So if the prize was 2 soul, I should end up with 5 soul if this works. So I hit test. Test passed. 5 soul, we did it. We transferred the lottery from the prize from the lottery to our account, and we are successful. That's amazing. And another reason I'm really happy is because you guys finished the smart contract. So like the video now if you were successful, if all your tests passed, because you guys know how to make a lottery functional app, right? So here's what we'll do, right? The next step that we need to do is take this code and call it within our front end app, which is going to be a whole setup in itself. So let's work on that. All right, so now we can finally start working on the app itself, and let's just take a look at something before we get too crazy, right? So this is the app. We could do an alt tab, and we should see this screen right here. And I want to draw your attention to a folder called utils, right? And again, a lot of this is set up for you. All right, so let's open up utils and let's take a look. There we have a constants.js folder. So click this. It should look pretty familiar, right? Master seed is master, lottery seed is lottery, ticket seed is ticket, right? This is why I said the testing from the Solana playground, if you understand that, this part shouldn't be as bad, right? When we do the actual code. Another thing you're gonna notice is that the program ID should match the program ID that you have right now. So ours is HY at the moment. So that's something to keep in mind, right, for later. There's this helper.js, which is a bunch of helper functions that we might call on later, might not. Next is this program.js, which imports our seeds and our program ID, right, from constants. And what it does is it literally gets our program. It's going to fetch our program from the chain. And we're also going to get a couple of things. So we're going to get the master address, right? So if you guys don't know or understand what's going on here, let's think about this. All right. How did we generate the master? That's how we're going to talk about it. So let's make this smaller. Make this smaller. Right? When we initialize the master, right? How did we generate the master PDA? We got it from seed, and all we wrote was master, right? And when we hit generate, we get this 7RX number, right? So keep that in mind, right? So when I have a function here, this is a front end function that says get master address. Okay, so it's asynchronous, right? Again, you might need to know some basic, not basic, but some JavaScript and React beforehand before this. And if you do want to learn more JavaScript, we do have a JavaScript crash course 2022. Be sure to watch that as well if you want to learn more JavaScript. We teach async functions in there as well. Anyways, shameless plug aside, what does this function do? Well, ignore public key, but basically this function right here is find program address. Okay, and we want to find a program address with master seed and use our program ID, right? So basically, this line right here is check or get the PDA from these seeds, right? So if I were to, again, show you the example, if I were to say from seed, all I said was write master here, put the program ID, generate, this will give us this PDA. That's what this will do as well, right? Return the master address. So it's literally fetching the master address. Okay, let's apply the logic to get lottery address. Okay, so before we look at the code of that, how do we get a lottery, right? How do we get a lottery address, right? It's right here. We get this from seed. What seeds do we need to get the lottery address? Whether it exists or not, right? We need the lottery seed. We need the last ID plus 1. And that's it. All right, so two things. We need U32, we need lottery, and we need 1. We generate that, 9C, right? And again, let's check. Was that 9C? It was 9C, so it's predictable, right? So with that in mind, we want to get a PDA with these seeds, with lottery and a big number. Right? Don't get scared by all this, but it's going to be ID, right? So get us a new address with that ID. Yeah? Cool. So this is going to be like the 1. And again, this .toArray-like is making it a format that the seed likes, right? That's why it says buffer from. And of course, put the program ID. So the same way that I just did it in this test right here to generate this PDA, we're finding if there's anything at that PDA based on the seed, right? So again, ticket address, we had 3 seeds. Here's your 3 seeds right here. Okay, cool. Awesome. So, and there's a function that gets the total prize, right? And again, we need this function because to get the total prize, remember how, let's say each ticket costs 5 SOL. I buy 2 tickets. The total prize is 10, right? So if the total prize is 10, we need to change that from lamp ports to SOL, right? Or the other way around, I believe. I convert lamp ports per SOL and convert it to a string, right? We want it to be a string so that we can see the total prize, and we want to display that total number here, 1,000 SOL or 5 SOL or 10 SOL, however many is the total right now. So does that make sense to you guys? That's what each function does, right? The name should give it away, and if not, I wrote comments for you guys, so hopefully it makes sense. So get confused, think literally what this is mean. Cool. So let's set it up, right? Because there's 2 things that we need to change now, right? The first thing we need to change is this. This should reflect our current program, and this idl.json, right? This is essentially a JSON file that describes our smart contract, right? So here's what I'll do. This is an optional step, right? But let's say I don't want my master initialized because I want to see that it's not initialized yet so that I can call it from the front end. I don't want to initialize it from here. I want to initialize it from our front end, right? So instead of like closing all the accounts, one way you could do this is let's create another smart contract and deploy that onto chain. So now there's going to be another smart contract. It's just going to have the same content really, right? Which means it's going to have a new address. Okay, so this was the original one. We're going to make a new one. Okay, and again, we don't have to write any new code. The cool part is if you want to make a new program, all right, just click new here, generate. This is our new ID, NE. Well, that's what it is for me. And I'm just going to hit build. Build successful. Hit deploy. Oh, I need 6 SOL. I have 5. Let's try Solana airdrop 2. Oh, success, failed. Okay, so it failed. I think it's because I need to switch to the DevNet. So if you haven't been doing this on the DevNet, make sure you're on DevNet. So let's try this again. Solana airdrop 2. There you go. So now I have 7 SOL. I like using the Genesis Go DevNet because there's 2 servers, because this one fails less, but you can't really airdrop from there successfully yet. But cool. I believe we built already, but just in case, build and deploy the contract to the chain. Right? Visually, what I did was I took this contract, put it on chain, and this is the address. So I'm gonna wait for this to finish, and I'll be right back. Alrighty, so the deployment was a success. Right now it says upgrade instead of deploy, and it exists on chain. The next thing we need to do is we need that IDL. So go to this IDL tab and hit export. All right. For you, if this is your first time, you should just see IDL no number. I just have 3 IDLs of my downloads. But if you have Chrome, double click this. It'll open it in VS Code. What you want to do is press Ctrl A and copy this. Right. I'll cut it instead so you can see it's like gone. And you want to, instead of this, you want to paste it here. Right. Technically, it's going to be the same thing if you follow it exactly, right? But make sure that you have your latest IDL here. I'm going to X out the downloaded one, and this is the updated IDL. You can see it's modified by this M. And again, for their constants, this is all the same. But what you want to do is change this to your program ID. How do you know what your program ID is? You can scroll all the way to the top. Mine's NE now. Yours might be something different, and I'll paste this there. And with that, that you did the setup, right, to connect your code, but it's not really calling anything. But all the setup is there. The pieces are there. We've got to put the puzzle together now. Sounds good? Okay. So it's been a while since we looked at our front end app. So let's draw our attention to the pot card, right? Because the pot card can have all the answers for us, right? So as you look, there's some temporary imports here, which is public key and the use state from React. But what I care about is this static data and the static states and these static functions, right? What do I mean by static? It means that they're not going to change. Like the lottery ID will always be 3 and the pot will always be 1,000, right? So let's just do a little side by side here. Something like this is totally fine. You know what? We can even do it like this. Cool. Awesome. Right. So what makes this static? Right. If I change this to like 50, I hit save. Notice how it says 50 SOL now, right? If I refresh, connect wallet, initialize master, it's still 50 SOL. Okay. What I want you to understand is how this all works, right? So if I hit refresh, notice how I don't see the buttons. Why don't I see the buttons? That's because of these states here, right? So the comments will guide you. This first state is checking if we're connected right now. So anything you write here is the initial state. So what's the initial state of connected? True or false? False. Right, but what if it was true? Say true. Save. We see initialize master, right? How did that happen? How come I see initialize master when I turn this to true, right? If you write this code by itself, it doesn't necessarily do anything. The secret is in all of the conditional rendering, right? So basically this. Okay, cool. Let's find Control F connected. Connected. Boom. Okay, cool. This line right here, line 70. This is something called conditional rendering, right? If connected is true, right? Let's see what I'm highlighting. Load this HTML, initialize master. If connected is false, show me the connect wallet button, which is right now, it should be wallet multi button, but it's this static button right here. Does that make sense? So with that logic, if I change this back to false, it's gonna show me the button. Cool. So let's change that back to true. Now you notice this, right? Now it says, now it's just the initialize master button, right? So connected is true. How do we make it so we see the rest of the buttons, like enter, claim prize, and all that stuff, right? Well, that's where this other check comes in. If is mastered initialize, right? This exclamation point is the opposite, right? So basically, if false, right, load all of this, right? But what if initialize master is true, right? So let's test it out. So let's say is initialize master, right? Or the comment for you to understand is the master created for the smart contract? All right, let's change it to true. Let's see what happens. True. There we go. All right, so if is master initialized is true, we should see all the buttons. All right, cool. Now there's another one. Another state is there already a winner for the lottery, right? If there is, we should be able to claim the prize, right? Because if there's a winner, we can claim the prize. So we can say true. Oh, cool. False. Yeah, is there already a winner for the lottery? So let's check is finished. Is finished. Enter. Oh, okay, so if it's not finished, right? If we're connected, oh, this is really good, right? This is some really good conditional rendering. So if we're connected and is we're not finished, we can enter the lottery, right? Basically, if this is true, that means we can't enter anymore, which is why I don't see the enter button, right? Another thing that we can change is if there's a winner, can that winner claim the prize? Let's see if it's true. Yes, we can claim the prize, right? So the secret to finishing this app is understanding all of the states. Okay. Another thing that's interesting is if I make this true, right, we see the buttons. The only one who can pick the winner of the lottery is the person who created it. So let's say I log in as a different wallet, or let's say I log in as Kazi's wallet. He wouldn't see pick a winner if he didn't make the lottery. This is what he would see, right? He would just see enter, and he can create his own lottery, right? So that's what const is lottery authority, right? Did the connected wallet create the lottery, right? So that's why you don't see that button. Yeah, so a lot of conditioning, a lot of conditionals, right? And what our goal is to take all of those states, all of this data, and make it dynamic. Okay, and the place that we are going to make it dynamic is in the context. So if you go to the context.js, you'll see all of this code right here. So if you're not familiar with context, the TLDR version is this, right? Usually, if I were to make, actually a good example is, a good example of this is we have a connected variable in pot card, correct? Right, it lives right here. But let's say I created that connected variable in index, right? How do we check if I want to check the connected here, right? It's going to say connected is undefined if I only define it in index. But what you could do is pass it down as a prop, right? This is a React thing. You can pass down connected as a prop to pot card, and then it knows what connected is, right? The issue is when you have a lot of components like children, and let's say I need connected to go here, I have to pass it down as a prop from index to pot card, pass it down as a prop from pot card to this one, from that one to this one, from that one to this one, right? And eventually, if it's a long set of components, that could lead to problems down the road, right? It's called prop drilling, and we want to prevent that. And it's just for organization purposes as well. We can create something called a context. So let me just make it here. Let's move Lamports over. A context, right? And that context can hold all of our variables. So we can make connected here. We can put is master initialized in here, right? And what we can do is take things from that little context or that store and bring it to where we need it. So I don't have to bring this to index and then pass it down. Or we can make it simple and say like, hey, I need connected in the pot card and I need is master init in the table, right? So we can call on our context. That's the visual way I like to see it, right? So here, all of this code that you're seeing, right? We're creating the context, and then we have to provide our app with that context. So this is the app provider, right? So what does that mean? The same way, right? This circle right here is our wallet connection, right? We need to make our context there as well. So I guess the better visual would be something like this. Let's make this blue. It would be something like this. Another circle, right? Like so, right? And inside we have connected, right? And I want to take that connected variable and put it into pot card. Okay, so we got to wrap our app with this app provider now. You with me? So let's go ahead and do that. So where does that need to go? I'd say it needs to go into the index. So let's go in index, and notice we need to put in that app provider, right? So if this is our app, we should wrap it. So the first thing we need to do though is import it. So we can say import app provider. You can see it here from the context, and provide right here. You can say app provider and take our app and paste it here. And there we go. So now we can use we basically just drew the blue circle around our app. So now we can take anything we create in here and bring it to wherever we want. So anything that we create here, functions, variables, put that in value, and that's essentially how we can bring it out. Basically, you're loading up your store, and once we get to the pot card, I'll show you how to bring it from that to here. We're good? Cool. So essentially, this is how we create our context. We have to make a function called app provider, and then here we're going to return that provider with everything it needs, and we're going to use our custom hook here, which is going to use our context so that we can call it later. So that's my explanation. I hope that makes sense, and it'll make more sense as we add more things to this. So let's get to it. Okay, so to start off, we won't need to see our app for a while. So let's go ahead and make this a lot bigger. Cool. Usually what I like to do is let's import everything we need. When I first built this, you don't necessarily know what you'll need until you're building and you realize, like, oh, I need this import. But for the sake of the tutorial, I want to tell you everything you need so that we don't have to import it later. So we'll say import bn. Bn stands for big number. You can get this from at project serum/anchor. Okay. We also want to import system program from Solana Web3.js, not Anchor. Program, and another thing is Lamports per sol. This will help with the conversion per sol. Okay, from at Solana/web3.js. Okay, so now we import use Anchor wallet from Solana wallet adapter React, and we also want to get use connection from there as well. Okay, and we also need to import something called base58 or bs58. I believe this is from Anchor. No, it's not. Base bs58 from, I think it's actually from bs58. Cool. Okay. Remember all the seeds that we made and the functions? right, from our utils, we want to import all those functions too. So we want to get lottery address, right? We want to get the master address. This is the functions that I explained to you before in our program, which is in utils. Get the program, get ticket address. Oops. There's also get total prize. And we can say from utils/program. Okie dokie. And then from there, let's say import confirm tx mock wallet. This again is also coming from the helper. Mock wallet from utils/helper. And another thing I like to import is toast, so we can get nice notifications when something works or not. All right, it's good to have that feedback. You saw this from the demo. Toast. Okay. This looks pretty good. And it's just because I have a habit of semicolons right now. We'll just do that. Cool. So all the imports are done. Let's see. The first thing I want to start off is let's make one of our static variables into the real thing, right? So it was in PodCard, right? So the first thing I want to tackle is this, is wallet connected, and it says true, right? So how can we do this? Well, to make this dynamic, we need to set up what connected is in the context, right? So what I'll do first is over here, right above the return, let's get our provider, right? So to do that, we can say const connection is equal to use connection, or not, is it use connection? Yeah, use connection, right? So use connection, and this is one of our hooks from Solana wallet adapter, right? Connection, again, will hold our connection if it's true or not, right? But from there, we want to say const wallet is equal to use anchor wallet, right? And another thing is const program is equal to use memo, right? Which is a React hook. Did I import that? Yeah, I need to get that, use memo. So make sure you have the hook as well so that you can use this. Use memo. What else do we need? Use memo. So for use memo, we need to check if there's a connection. We can return get program, and get program is our function from our helper, right here, which is going to fetch the program, and it's going to return the program. So return our program, right? But we do need to pass in things to our that function, right? We need to pass in our connection, our wallet, and if for whatever reason the wallet isn't there, we do this question mark, we'll use the mock wallet, right? But if it should be there because we set it up with this. Okay, cool. We got a program. And comma, run it if there is a connection, and if there's a wallet, try again. Okay, run this. Cool. So we have, anytime I say program, it's gonna hold all the information about our program, which I'll show you in just a second. But the main thing that we wanted was this wallet here, right? So what I'll do is in our value, we can say connected, right? This is a variable, and this variable is gonna hold wallet if there's a wallet. Get the public key. If there's a public key, it's either gonna be true or false, right? So essentially, connected will be either true or false depending on if we're connected, right? So that's what makes sense. So if this is true, we can go into PodCard and we can comment this out for now, And at the top of our pod card, let's take what we need from our context. So first thing we need to do actually is go above this temporary imports comment. We can say import use app context. All right, this is our little context, and it's in here. So we can say const object, and we can say get me connected from there. Okay, and this is coming from our use app context. All right, so comment here, and we'll console log connected connection status. Okay, cool. So let's see if we can see that real quick. App context. Oh, did I already do this? Oh, I did up here already. So we can remove the import. So you don't need to write that, guys. Sorry, I already gave it to you up here. I'm too nice. Cool. So we open up our app. Let's see, false connection status, right? This should be true at some point, right? Which is why we can set it to that. Cool. And since we're gonna slowly remove this, we can put back our wallet multi button. Wallet multi button. This is self-closing. And I believe there's another place where this goes. Wallet multi button, and right here, wallet multi button. Cool. So let's select the wallet, Phantom, and there, look at that, guys, it already works. All right, so I refreshed it, right? So now it says, first it was false, right? But once I connected my wallet, if you remember our context, this becomes true, and this should become true. So now we're there, right? It's automatically gonna connect, and once it recognizes that there is a valid Phantom wallet connected, the flag will set all these buttons, right? And again, at the moment, these don't work, but our goal is to make it dynamic just like that. All right, so on to the next thing. I'm gonna go back to our code, and let's start setting up a use effect. And if you didn't know, use effect is a React hook that's basically gonna do something when we load our app, okay? That is the simplest thing I can give you right now if you don't know what use effect is, right? But what we wanna do is set that up. So in our app provider, I'm gonna go over here, and I'm gonna say use effect, like this, parentheses, and this is how we can start using it. Use effect takes an anonymous function. It's very similar to use memo, right? But what I want to do with this use effect is run a function called update state, right? And again, if you were to run this right here, right now, it would say update state is not a function because it doesn't exist yet. Okay, but after this anonymous function, put comma, and then an array here. This is what we call a dependency module. And if you put program in here, basically when we first load the app, run update state, or when the program changes or this gets updated, run this again. Okay, so that's set up for later. Let's go ahead and define what the hell update state is. So let's start writing it. That function const update state is equal to async. It's going to be asynchronous. And let's figure out what we want to do. The first thing that we want to do is that if there is no program, this shouldn't run. So let's just put return. It's just a check. Okay. But what we want to do is a try catch. All right. This is usually what you do when something's asynchronous. You want to do a try catch. It's fine. We can just say error for now, and then we can say console.log error.message. Cool. Okay, as I was saying, I want to do a try catch, and that first thing you want to check is if there's a master, right? So if for whatever reason there is no master address, that's what this is saying, then we need to get the master address, right? So how do we get the master address? Think back to our folder here. in our program, how did we get it, right? We need to call this function, right? We're getting it from its seed. So we're going to call this function, and we actually imported right here. We're going to call this function. But then the next question is, how do we save the master address? Because after we get it, how do we save it? All right, so that's where another hook called useState is going to come from. And if you remember the pot card, that's where this is what a useState is, right? It's basically saving the state that this variable is in. Is it true? Is it false? Is it an array? Is there stuff in that array? Right? You can do that by state. So what we want to do is we're going to end up with a bunch of state variables in this app provider, right? One of the first things we can write is const master address. Set master address, okay, is equal to useState. Okay, cool. So there we go. So now, if there is no master address, which that's true, there's no master address right now, we need to get the master address. So how do we do that? We can say const master address, or you can call this variable the same name, it's fine. You can say await get master address. It's a function, right? Otherwise, if I didn't make that function in my utils, I would have to write out that function here. This is so we can just organize it a little bit better. Cool. So then how do we save the master address? We can say set master address is master address. Okay, cool. So now we have it, right? So that means this if block wouldn't run, right? So another thing we can do is say const master is equal to await program. Right? So remember I said when I say program, it gives you all the information. We can get the actual object, right? So yes, we got the master address. What we need to do now is fetch the object, right? So when you saw me do a fetch all, oh yeah, there's no master. But before there was something here, right? There was the master account. You can fetch an individual account by just writing it right here. So this is how you get the singular account. You can say program.account.master and then fetch, .master.fetch, and what you want to put inside here is the master address, the public key that we get from here after we fetched it. And or if for whatever reason it's not there, we can say await get master address again and get it. All right, so that's what this question mark is. So if it's there, this will run. If for whatever reason it's not there, we can get it right here. Cool. Does that make sense so far? Another thing that we should do is set initialized, right? So we need another state. All right, our states help us keep track. So let's say const initialized, and that shouldn't be capital, it should be lowercase. Initialized. We can say set initialized and set that equal to use state, and the default state of initialized is going to be false. And just check pot card. Yeah, so that's essentially the same as this, is the master initialized. So if it's initialized, we're good. If it's not, false. Cool. All right, so if we're able to fetch a master, right, we can set initialize to true. Awesome. Yep, and this is just update state. It's gonna run that. It's gonna do these checks. Let's console log it. Console log master address, because there shouldn't be a master address. Okay, let's hit refresh. Select wallet, phantom. Oh yeah, account does not exist. So there is no master, but because there's no master, we shouldn't see these 3 buttons. We should see initialized master first. All right, so what we need to do is we need to pass something in this value here, so to keep track of that state, right? So what was it called? We called it is master initialized. I mean, yeah, well, let's just keep that same naming. We could say is master initialized, and give it a new name, like put initialized here. So whatever the value of this initialized is going to be the same as is master initialized. Basically, I'm giving it a nickname, right? If your nickname is Robert, if your name is Robert, here's Robert, I'm gonna call you Bob. Right, that's basically what it says. And the reason you see squigglies is because we need a comma here. So this is the nickname of initialized, right? So let's bring it, save it, let's bring it here. Oh yeah, we can erase this now because yeah, we do have a wallet connected. And we have this guy now. So we can erase this. And in our context, so let's get is master initialized, comma. So let's hit save and let's see if it works. Select wallet, connect. Hey, all right, that's true, right? There is no master account, and there's proof in our backend right here. No master account. So now when I click initialize master, right, we need to be able to create the master, right? So how did we do it in our Solana playground, right? We tested it by running it here. We want to now run it in our front end code. All right, so that's exciting. Okay, so now how do we call it in our front end? I'm glad you asked. What you should do is let's go back to our context. And let's scroll to where the end of update state is, right? So underneath update state, we can make another function called const init master, right? And here we can make a comment of call Solana program instructions here. So anytime we're calling something from our smart contract on the blockchain, this is where we're going to call it from. So it's going to be called init master is equal to async. Boom. And if you don't know what I'm saying, basically over here, we want to call our smart contract, right? It's this one. We want to call our smart contract from our front end. So basically, we're going to make a function in our context that talks to our smart contract that runs the function that will create a master. Okay? So me just writing this function right now, this is not me calling it just yet. Right? I'll show you what's calling the Solana instruction. Okay, so first thing you want to do is a try catch right here, error, and we can say console.log error.message. Okay, cool. So yeah, what do we want to try here? Well, we want to say const tx hash, right, to transaction hash, because every time you call something from the Solana program, that counts as a transaction, right? And this tx hash is the variable that holds all the information. So how do we call that Solana instruction? You need to say await program, right? Because program is going to hold all of the information. It holds the accounts, right? We did our .accounts, but it also holds all of the instructions, and it's going to hold it in .methods, right? So .methods, and then you want to say .init master, the name of the method, right? And if you remember, we called it init init master right here. So get the name of the function. If I want to call create lottery, we say create lottery, but this is init master. And again, it doesn't matter if I press enter here, it's the same thing, right? Then you want to get the .accounts, right? So what am I doing by when I say .accounts? This is the context, guys. You understand? All right, so every here is where we put all the context. So what's the context of this? I don't know. So all the testing practices coming in. So the accounts that we need is a master and the payer, right? And how did we get the master? We got it from the seed, right? So what we can do here is say master and then underneath we can say payer, right? So I believe that's what we called it, right? Payer. Oops. Payer. Right? So that's good. Payer. And the system program. All right. So don't mind the squigglies. We'll fix it in a second. So if we want to tackle, if we want to tackle the master here, we have to say semicolon and then put semicolon and then put the public key. We got to put a public key here, right? But we can't just write public key. We want to write master address. Wow. Why are we writing master address here? Well, if you remember where master address comes from, right? If there's no master address, we're gonna get the master address, right? And how did we get the master address? We're gonna put in the seeds, right? That's why I asked you to understand what this program.js does. All right, we're gonna put the master, the string, and we'll get an address. All right, that's the same as me doing this. Boom, JA, right? Cool. So because we set up that program.js, it's gonna make our lives easier here. So all you have to write is master address here, and we're good. Because the value of this is gonna be the public key of the address that we generated from seed. And now for the pair. Oop. And now for the pair, it's gonna be the wallet.public key. Come. And then for system program, it's gonna be system program.program ID. That's how you get the program ID we need. I'm not sure why this is freaking out. Did I miss something? Oh, I think I know. Sorry, accounts should have it should be all in an object. X this out and put that all in here. There you go. No more squigglies. We're good to go. So yeah, I'm giving our function, our Solana instruction, the context, which needs master, payer, system program, master address, generates it from seed. I put in my authority. The program ID is already here. Cool. The only thing you need to do is make sure you type in .rpc, because we need that. And then we can say await confirm tx, right? Because I want to confirm that my transaction went through, right? That's what, is that here? I think it's in a helper function. Yes, right? Because we want to validate that our transaction went through. Okay. And by saying await confirm tx, pass in the transaction hash, and then we can say pass in the connection. Cool. And then after that, we can just update the state. Right? Remember we made a function called update state. So it's going to initialize the master, which will then update the state, which will then do this check, which will then set the master, right? And I'm trying to think if there's anything else I need in here. Master. Oh, okay. Yeah, we don't need to worry about this just yet, but it should make this true, right? Set initialize to true. Because the reason why it said account not found is because we got to this point and then it failed, right? It couldn't get a master address. It doesn't exist. So it went to the catch, and that's why we saw account failed. But since it doesn't fail, it's actually going to set this to true. So let's see if that works. Let's go back to our app, moment of truth, select wallet, phantom, inspect element, console, right? Count does not exist. Let's click initialize master. Ooh, okay, set is master initialized. Oh, duh. All right, so the reason why this failed is because, yes, we created the function, but notice how it's kind of grayed out. We need to pass it in through our context and then plug it into that button. All right, I can't forget that step. So let's put a comma here. Let's say init master. Okay. So now this shouldn't be grayed out. And now when we go to pot card, where is our context? We say init master, right? And there's a function. This is the static function right here, init master. We can get rid of that now, right? And we don't have to plug it to the button itself because it has the same name. So right here, on click init master. So now we should be good to go. Let's select wallet, and now it's init master. Ooh, okay. All right, I crossed my fingers, but if you see this approved transaction, this is a very good sign. And cool, we can actually see how much SOL that we use. We can hit approve. Hey, look how it automatically changed. We made it dynamic, right? And I forgot to put the toast, but usually it'll be a notification here that says it was successful. All right, so now there's a master, and the cool part is we can check it on this end too. We can do a fetch all. Boom, there it is. All right, last ID, bam. Cool. So now there's a couple things now I want to check. All right, we should see if there's a the lottery ID. Well, actually, no, we can't see the lottery ID. So let's work on creating a lottery next. All right, so you want to figure out how to make a lottery. Let's go back to our context, right? And let's set it up. All right, so to set it up, we just have to make that function again. So underneath init master, let's go write create lottery. So we say const create lottery, right? Is equal to an asynchronous function. And the same way we did this, it's gonna be very similar, right? So what else did I do here? Oh yeah, we could say toast.success. So next time we'll see the notification. Master or initialized master. Initialized master. Cool. And just in case it failed, we say toast.error. And you say error.message. Perfect. Okay, cool. So that we just finished up the init master, but to create the lottery, what did we do first? We did a try catch. Error. And we can console.log the error.message, or we can also do a toast.error and put the error.message because it's going to disappear. I don't want it to disappear. Cool. So for the try catch, what are we doing? Well, we want to set up the lottery address, right? So you want to say const lottery address, address is equal to, get lottery address. But now the key is this. We need to pass in the lottery ID, right? And again, that's because this function is essentially doing this part, right? It's going to create lottery, it's going to this, and we're going to generate from seed, which is lottery, right, not all caps, but lottery, which is the, the last lottery ID plus 1, which would be 1, and we generate, it should be 4Q, right? I don't think it actually does the plus 1 on the front end though. Let me check the Control B, and let's quickly go to our program and see how it works. Okay, cool. So it takes in an ID, right? So that means we need to plus 1 before we pass it in. So let's go back to context. So basically we want to say lottery ID plus 1, right? So how do we get the lottery ID? The first thing I would say is let's make a state for it. So let's go up the top. And again, like I said, we're gonna end up with a bunch of states here, guys. So let's say const lottery ID, set lottery ID, set it equal to use state, and we can leave it blank. Yeah, we can leave it blank because we're gonna set it anyways. Cool. So when do we get our first lottery ID? Well, if you remember why we set up the master, we get it from master.last ID, right? So do we have access to master? Right, so we're checking if we don't have master, we're getting it. If we don't, we're saving it. Or we can even erase this. So then we get the master, the reason why we stated it in this variable is because now we can say set lottery ID to master, and then how do we get the last ID from this? You can say dot last, let me see, last ID. So literally last ID. So now after this runs, when I say lottery ID, this should hold the value of 0 currently, right? So we'll always update. So basically, whatever the lottery ID is, plus 1, right? Because this function is only going to run if there is a master. So there goes that check. So I think you're with me now. So after we get the lottery address, this would give us a public key. Right? That's the type. It's not going to give us, this lottery address isn't going to hold a number. It's going to hold the PDA. Okay? So now that it's holding the PDA, you can take that information and say const tx hash, because we want to confirm this later. Oops, tx hash is equal to await program.methods. And what method do we want to call, guys? We want to call dot create lottery. Okay, and we want to say new bn. Right. Cool. Why do we want to say new bn? Because when we create a lottery, we need to define the ticket price. Okay. Remember when we put the ticket price here, we said we put 9 zeros, 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, and then we put 1 here. This will cost 1 sol, right? The price isn't hard coded on the contract. We can actually determine the price right here, right? So if I put 1 here and say dot multiply new bn lamb ports per sol. This is the same thing. This would generate the same number as this, right? 0, 0, 0, 0, 0, 0, 0, 0, 0. It should be 9 zeros. Cool. So this is 1 sol. This would give me 1 sol. And you know what? Just like the demo, let's up the ante. Let's give it 5. Right. So how much does when I create a lottery, by default, it'll be 5. Right. If you want to make this dynamic, you can put an input field somewhere here. Set the state. And when you create a lottery, that's how much that lottery price would cost. All right, but for now, to keep things simpler, we're gonna put 5 sol. Okay? Cool. So after we create that argument, let's pass in the context. And what context does this function take in? I'll tell you. It takes in a lottery account. Oops. It takes in a master account. Takes in a authority, and takes in a system program, of course. Cool. So don't worry, we're gonna define all this. So lottery address, we actually get it right here. All right. This is gonna generate it from seed, and we're gonna put in a variable of lottery ID plus 1, and we're gonna say lottery address. Cool. So what is the master? We should already have the master address. It's in this state. Right, so that's nice and easy. The authority is also easy. We can say wallet, right, our wallet, and get the public key. And then for system program, security standard, you say system program dot program ID. And then you can say dot RPC right here. Oops, RPC. And we want to confirm the transaction, so we say confirm tx hash, right, and connection, right? So if you're coming from the to-do app, Airbnb, or the blog app, this is like the proper way to do everything, right? So, and again, there's more than one way. I'm not saying there's a right or wrong way. It's nice to confirm the transaction after it's done. We then want to update the state, and this time I want to see a nice message. So we'll say toast.success. And we'll say lottery created. Okay, cool. Awesome. So let's take this create lottery, it's grayed out, and put it right here. Oh, don't know. Oh, I accidentally made a whiteboard. Sorry about that. Cool. So let's take it and put it right here. We can say create lottery. And if we do that, we need to bring it into pot card. So we have the static create lottery. Let's go ahead and erase that. Let's erase the static connect wallet. All right. This is basically our to-do list right here. Yep, over here. After init master, we can say create lottery. And we don't need to plug it into the button because it has the same name. I made it nice and simple. Okay, cool. So let's go back to our app. Select the wallet. And we want to create the lottery. Hey, okay. So again, this is the first good sign that we can, it's going to ask us to sign and approve. And let's hit approve. We wait. Hey, lottery created, right? So we made a lottery. We can double check this on our back end by fetching. And there you go. We have the lottery ID. We don't know the winner. We have the last ticket ID. And we have the authority, right? So who has authority? 8T, which is the one who created this lottery, right? So a couple things here. Now this is technically incorrect, right? Lottery number 3, it should be 0, right? Same thing with this. This should be 0 SOL because there's nothing in the pot. So why don't we work on those two things? Okay, so like I said, we want to change these static variables into the actual variables. In other words, make it dynamic. It's actually pretty simple, right? So if we go back to our code, in the pot card, this is the static data we want to change, right? Right now it's 3, the pot's 50, right? We go to our context, let's actually make those states. And the cool part is the first part's done. We already got a lottery ID. Right? We just need to make const lottery pot, post pot, and say set lottery pot. All right, so we'll just set this temporarily, state, boom, and yeah, we can leave that blank. So let's start with lottery ID. The cool part is we already have that set up. We're getting it from the master. And I'm gonna put all of our instructions at the bottom. But for lottery ID, we'll say lottery ID and comma. And once we do that, we can hit save and we can go to pot card. Let's bring that in, lottery ID. And now notice how there's 2 lottery IDs. That can't happen. We can erase this now, save, and take a look, guys. Lottery number 1. And is that accurate? Right, because ID is 1, we got lottery number 1. So when I make a new lottery, this will automatically change when I update the state, right? So that's why I made an update state function. So it just literally updates our front end with the correct state. Now let's work on the pot. So yeah, this is our static one. Go back to our context, and you know what? We can go to the top. Let's put it above init master, and let's make a get pot function, right? So that actually should be pretty simple. We can say const get pot is equal to async, and we can say const pot is equal to, we have a function that does it, get total prize. I gave this to you, and if you're curious on how it works, feel free to check it out in program. All right, get pot, right? Cool. So get total prize, we just gotta pass in the lottery, right? What is the lottery? Okay, so that means it's a state that we have to set, right? Because we need essentially the address of this. So let's set up that state. Over here, const lottery set lottery is equal to use state, and we can set this to empty, I believe. Yep, we can set it to empty. And another thing that we're going to need to do is first set what that lottery is, because right now it's nothing. So when we pass it into get pot, it wouldn't work. We got to go to update state, boys and girls, and we need to go underneath set lottery ID. All right, we need to get that lottery address. So how do we get the lottery address? We can say const lottery address is equal to await get lottery address, and say we can get the lottery address by passing in the master.lastID. There you go. And we don't need to +1 here because we're not making a new one, right? We're just fetching the current one based on the last ID. So from there, we can say, oh, actually, no, this is getting a different state. So we need 2 states, actually. So we need to say const lottery address. This is going to help us later. Set lottery address is equal to use state. Cool. Awesome. All right, so yeah, this first one we didn't really need quite yet, but since I'm already here, we want to set lottery address to that lottery address. So the same thing with the master, we can call this one instead because that's going to be the current lottery, right? So set lottery address, and now for the real thing, to get the lottery pot, you can say const lottery equals await program.account.lottery, right? Because we want to fetch a specific lottery. So if we're going to fetch one account, we want to fetch it by the lottery address. So now that makes sense. We want to get this first and didn't do this, right? So let me show you what I mean. Basically, what we did with these 2 lines of code, or this line of code specifically, line 57 for me, is if you go to your app, go to here, let's copy that public key, and let's just do a little bit of this. Boom. So notice how I'm not fetching anything. I paste in that public key. This is lottery address right here, this right here, and I'm taking that address, I'm pasting it here and fetching it, and then it gives me a singular object, right? So again, in our code, we get the public key, we fetch an account with that address and store that object here, const lottery, and then to save it, we say set lottery is lottery. Okay, cool. So now when we do get get total prize, we just have to say get total prize lottery and then set lottery pot and set it to the pot. Right, so this is why we have so many states. We gotta keep track of all of this. Yeah, not an easy build, but if you guys made it this far, I'm really proud of you. So let's do get pot comma, and well, not get pot comma, my bad. We can say lottery pot. Yeah, lottery pot. That's what we need. And what did I say before? I said I wanted to put all the functions there and all the data here. Cool. So now we got lottery pot in store. So we can go here and say lottery pot, erase the static data, right? So we can cross that off our to-do list. We only have this left and all these functions. We can save, and now what is our pot? Should be 0. Yeah, it should be 0 sol or nothing. Oh yeah, that makes sense. There's nothing in there. But if you did want to see a number, right, if it's 0 sol, we can set our initial state to that. So let's go to context. All right, there's literally no Solana in there, so that's why it's literally nothing. So let's do lottery pot here, 0. We might change this actually. All right, now we're good. 0 sol. Lottery pot. Oh, I see why it's still saying 0. It's because we didn't call get lottery pot. We have to call the function, and we want to call the function. We need to make another use effect. That's what I'm thinking. So let's make another one. So this use effect right here, this one is going to get pot. All right, so we're gonna get the pot, and if it does work, it'll set the state. So now if I hit save here, last ticket ID, lottery. Okay, so it's not sure what lottery is. All right, let's troubleshoot this. So to troubleshoot this, oh wait, maybe you should have a check here. If there's no lottery, return. There you go. Yeah, that's because we need to wait for it to fetch it, and then there'll be a lottery. Otherwise, it's gonna run that command before it's even there. So that's why we need to check this first. So it's gonna keep running this code, but once there is a lottery, get the pot. So now it's 0 sol, and that makes more sense. It should be 0. We don't have to initialize the state with 0. And yeah, there you go. We set the lottery ID and the lottery pot. Alright, so what's next, guys? Well, let's take a look. If I go to my app, we need to be able to enter and buy a ticket. And our tickets are pretty expensive. It's 5 Solana. Alright, so in order to buy a ticket, we have the button set up. We just need the function. So we can scroll all the way down to here, and let's make a function buy ticket. So we say const buy ticket. And I can go a little bit faster now because you guys should start seeing the pattern. But it's gonna be async, right? What do we put here? Try catch. All right, error. I'm not even gonna do the console log because we can just do the toast dot error and say error dot message. And for the try, you guys know we're buying tx hash equals await program dot methods. Okay, and then what method do you want to call? It's going to be buy ticket, and then it's going to be lottery ID. Right, we have this state, right, and it should be 1 because that's what we're on. And we could do another dot accounts. This is our context. This expects an object. And our context is what? Lottery, ticket, oops, why can't I do ticket, and not ticket seed, sorry, ticket, and the buyer, I believe, right, we call it buyer, and we need system program. All right, these are all the accounts we need, all right, just to prove it to you. When I buy a ticket, we have lottery, ticket, buyer, system program. Lottery, ticket, buyer, system program. Right. Okay. So again, we should have all of these. You can say lottery address because we have the state now, which is so nice. I don't have to say const lottery address and then fetch it here. We already saved it in our state, so we can reuse it. So now the key part is ticket. We don't have this saved, but we can get it by saying await get ticket address. Right, I set up a function in our utils, and it's going to take in two things. I believe it's going to be our lottery address, which we have, and the lottery, which is our object dot last ticket ID, right, plus 1. Right, so this ticket ID will be ID 1. Cool. Now we put a comma here after that function, and we say the buyer is the same as us, which is wallet, our wallet, dot public key. Okay, and then the system program is capital system program dot program ID. I'm sorry if this is boring because it's the same thing over and over, but this is really cool because once you understand how to do this pattern, you can literally make any app you want. You can make Twitter. All right, we made Facebook together. You can make a better version of that now. Right. Yeah. Yeah. So then from there we can do .rpc, and we can say await confirm tx, which is our helper function, tx hash, and we pass in our connection. Cool. And we say toast.success, and we say bought a ticket. Let's make a capital for emphasis. Okay, yeah, we're good. So this is our function, buy ticket. Let's go to the bottom here and say buy ticket. Cool. And we bought the ticket. We go to pot card. We got to bring buy ticket. And you see squiggly because it already exists. There's our static function. We can erase that now. We only got 2 static functions left. Right? We don't need to put it in the button because it should already be there. So back to our code, we have 1 lottery, it's 1. All right, let's hit refresh actually. Boom, 1. We can't pick a winner yet. We can't create a lottery, right? This doesn't mean anything. But if I hit enter, good sign. And look at that. It's literally going to take 5 Solana from me. It tells me how much it's going to take, plus tax. Of course, it's kind of like tax, network fee. But let's look. Yeah, something went wrong. There's our toast. But let's look into our phantom real quick. I have 18 SOL, so after this, I should only have 13 SOL. So let's see if it actually takes my money. And that 5 SOL should be updated in our pot, right? Because we're going to update the state, right? So what we need to do is not forget, after we confirm the transaction, we can say update state, right? Don't forget to call that. We're going to call update state every time our transaction goes through, because if we update the state, our pot will get updated and anything else. So let's select wallet. Let's hit enter. 5 SOL. Approve. Bought a ticket. And look at the pot automatically updated. We can check how much money we have. Report. We spent 13. All right, and just for fun, let's make it interesting. And let's switch to my other wallet. Let's see, does my Kazi wallet have anything? We have 7 SOL. Okay, so 50-50 shot. Will Kazi win money or will I win money? Right, so let's make Kazi enter. It's gonna cost him 5 SOL. 10 SOL, right? So that means either I can win or Kazi can win. But who is able to pick a winner? Kazi shouldn't be able to pick a winner because he didn't make the lottery. Only I should be able to pick a winner. So yeah, this pick winner thing should be us. Right, it should only be us. So maybe let's set that button before we create the functionality. But other than that, that's how we buy a ticket. Let's go. Well, so how do we make it so only the person who created the lottery sees the pick winner button? Well, if you remember how our pot card works, we got to figure out is lottery authority, right? Because if this is false, right, this is what Kazi should see, right? But what I should see is this. Okay, so how do we make this dynamic? It's going to go into our context and let's figure that out. The cool part is we don't need to make any special function. We can actually just go in here underneath lottery pot and we can say is lottery authority colon, right? And I'll hit enter here and we can say we're going to give a nickname to something. Right, what are we going to give a nickname to? And actually, we can even just write it all in one line so it's not confusing. We can say wallet and, oops, lottery and, oh, make sure it's double ampersand, and wallet dot public key dot equals lottery dot authority. Okay, I know that was a mouthful, but basically, if there's a wallet and a lottery, and the wallet's, like my address is equal to the lottery authority, right? So let's check what the lottery authority is if you don't know. If my wallet address equals this authority here, 8T, which it does, 8T, we should be able to see the pick winner button. So all of this will either be true or false. And it's going to be in this name, his lottery authority. So if I hit save here, let's bring it to the pot card. Underneath, oh, we should organize this. Lottery pot shouldn't be here. It should be right here. And we can say is lottery authority. And we can get rid of this static guy right here. Static state is gone. Oh, we can also erase this comment here. Nice. All right, we're making a lot of progress, guys. We still have static history here, these 2 states, these 2 functions. All right, we're almost done. So let's hit save. And now when I select wallet, we can see the pick winner. But what if I log in as Kazi? All right, so I'm going to switch wallets. I'm going to go to my Kazi wallet. Boom. You don't see it, right? It's all automatic. It's not static anymore, which is amazing. So let's switch back to here, my wallet number 1, and let's pick a winner. And we can claim the prize, right? That's the next 2 things. But again, pick winner is static. Let's make that function. Okay, you know the drill. Where are we going, guys? We're going to context. And underneath by ticket, let's make pick winner. So to pick winner, I'll just say const pick winner. Okay, pick winner is equal to async, and we say try catch. Okay, error or error, and we can say toast.error is error.message. Okay, but in this try catch, we'll set up our tx hash is equal to await program.methods. Okay, and what method are we calling? We're calling pick winner. And what arguments does pick winner take? Does it take any? It takes in lottery ID. Aren't you glad you save it as a state? Otherwise, you'd have to literally type in lottery.lottery ID. And if you didn't do that, you'd have to fetch it here, right? So you want to pick a winner. You want to set up your accounts. This is an object. This is your context. So what do we need? I'm not going to write all of it out anymore because you guys know the idea. The first account that we need is the lottery, which we have when I write lottery address. It's saved in our state. We have the authority, which then we can write wallet.public key. And that's it. Believe it or not, that's it for pick winner. And we can write .rpc, right? All the meat and bones was in that pseudo random function of pick winner, if you remember. Okay, so .rpc, and then we await confirm tx hash and connection. All right, update state. All right, because we want to make sure after we confirm the hash, we update the state, and we give a nice little message that says, hey, picked a winner. Okay, cool. Awesome. Yeah, so we have the function update state to success. What we need to do now is make sure we pass that in here. We say pick winner, but there is one thing that we do need to do is when we connect our wallet, when we pick a winner, we should see recent winner right here. It should update this. So that means we need to look in our update state, I believe. I'm trying to think. If users tickets. Yeah, okay. So we gotta do a couple of things then. Let's go back into here and let's go back to our update state function right here. Cool. So we got the lottery address, we got the lottery object, and now the first thing that we're gonna need to do is get the user's tickets for the current lottery, and you'll see why in a second, right? So just follow along with me, that makes sense. Let's do a quick check here. If there's no wallet, and put a question mark here because it won't run if there's no wallet, .public key, then we're just going to return nothing, right? So basically, if there's no wallet, this shouldn't run at all, right? Just leave, right? But if there is, I want to say const user tickets equal to, how do we get all the tickets, right? Basically, what we want to do is go to this ticket here and do a fetch all, right? And there should be 2. But how do we do that in the front end code? This is how. You say await program dot account dot lottery. Well, not lottery, sorry. We need a ticket. Yep. Dot all, right? And what you need to do is filter it by there's a way to filter it, and what I'm going to do is copy and paste this one. So this is the only thing I'll copy and paste for you guys because there's a certain way to filter it. You don't necessarily need to do this step. If you remember the Airbnb, I didn't necessarily put a filter here, but what you want to do is something like this. Boom, right? Yep. Couple conversions here, plugging in our wallet, and there you go. This is what we call the author filter. Okay, so again, if you don't want to write out, to pause the video, copy this right here, This is the filter for all. You can also switch to the other branch, get that piece of code there, or go to our GitHub and find that solution in the main branch. But basically, it's going to filter the user tickets, and once that's done, store it in this variable. Okay. So now that we have all the tickets, we want to check whether any of the user tickets win. All right. So, yep. So to check if they won, it's kind of complicated as well. Make a variable called user win, set it equal to user tickets dot sum, right? And you're gonna write t, an anonymous function here. You're gonna write t. What's the name of that? Say t dot account dot id, and t stands for ticket, by the way. You don't have to write t. You can put ticket. If that makes more sense. Is equal to, how do we know what ID wins from that lottery? You say lottery.winner ID. Because when we pick a winner, this will have a value. It's not going to be null, right? Because I believe right now, if you look at it, it's null. But when we pick a winner, like we're about to do, this is not going to be null anymore. It's going to be something. All right, so check if there's something, essentially. If there's a winner, and if there is a winner, right? So this means if this is true, set and save that user. So I guess that means we need to make a state. So I'm gonna go up the top here, say const set, is it winning ID? Yeah, set winning ID. Yeah, so we're gonna say user winning ID and set user winning ID and equals use state, and this is gonna be false by default because there shouldn't be a winner ID just yet. Another thing you want to do is there a winning address that we should set? Oh no, this is it. We can use user winning ID and user winning ID. Set user winning ID. Cool. All right, so I think we're good. So yeah, if there is a user winner, we want to set user winner ID to that lottery winner ID. All right, so this is the check if there is a winner. This is set it to that winner. Set the ID to that winning ID. Then we can do else and say set user winning ID, set that back to null. Okay, and then there should just be a catch here. And I think we're good. Okay. So what can we do with this, with the winning ID? Well, I can do a couple things actually. We can go down below here. All right, we have a lot of things already, but we can go underneath, in between init master and create lottery. We can say is finished, right? Because when we pick a winner, we should finish the lottery, right? So lottery. So if there's a lottery and lottery.winner ID, right? Because after that check on update state, this shouldn't be null anymore. It should be something. Okay, and I believe in pot card we have is finished, right? If the winner is the winner, can that winner claim the prize, right? So we need a can claim. So can claim, right? It's gonna be lottery, if there's a lottery, and there is not a lottery.claimed, right? Because remember, this is true or false, right? And there needs to be a user winning ID. Okay, so basically, can they claim it, right? This will check if they claimed it or not. So if it's false, this would be true. And if this is true, like all three of these have to be true for a can claim to be true. Otherwise, it'll be false. Hope that made sense. A lot of checks. So with that said, we can get is finished, and we can get can claimed. Oh wait, I want to put these guys right here is finished can claim, and we get 2 squigglies because these are our last states. So let's go ahead and erase those things. So now, there we go. What was I doing again? Oh yeah, I wanted to check this really quickly. Boom. There's no recent winner yet, so let's set this up. So I want to set up the recent winner. To do that, we're going to need lottery history. Right, so basically there's an array here, and prize 15. Cool. Yeah, so this recent winner is coming from lottery history. We can get lottery history by looking through all the tickets and then checking if there's a winner in each of those tickets. And once it finds that winner, it'll take that winning address and put it here. All right, so basically looking through our history, looking through the tickets, and then saving it. All right, so let's make that function. So we can say const get history is equal to async, and say if there's no lottery ID, then there's no point, we should return. It's one of our edge cases. Next, let's set up this history. Remember, there's going to be an array, right? And it's going to hold, it could hold more than one object, right? But right now it's only holding one. And it's basically all the recent winners, right? So if we have multiple lotteries, it's always going to have the last item in the lottery that gets pushed. Does that make sense? So technically, if I had this, it would give me this public key, right, as the recent winner. Okay, cool. So we want to make this dynamic now. Again, this requires you to have a little bit of knowledge of for loops. So again, if you don't know, just follow along. I'm just going to say for const I in. This is a for in loop, and we're going to make it a new array from the lottery ID. And then we say dot fill null. All right, value to fill array section with null. And then, oh yeah. So now we're looping through this array, and we want to say const ID is equal to lottery ID minus parse int I. Right. So this is a kind of like a coding problem here, right, that we're solving for. So to get the history, we're gonna need to do a couple things, right? If there's no ID, we need to break. But if there is an ID, we can keep looping. So we want to do a lottery address is equal to await get lottery address and pass in the ID. So again, this is getting all the history of the recent winner. So there's going to be multiple lotteries, right? So get me the first lottery, get me the second lottery, the third. But if there's no second or third, break. That's like the English translation. Cool. So once we have the lottery addresses, right, we need to then get the lottery objects. Right? So we can say program.account.lottery.fetch lottery address. So these two pieces of code are going to be running multiple times, right? So right now there's only one lottery, right? So this is not going to run multiple times. It's going to run once probably. And from there, we need to get the winner ID. So it's going to be a lottery winner ID. So it's going to go through all the lotteries. It's going to go through all the winners, right? And if there's no winner, so let's say like lottery 1 and lottery 2 is done. It's looking at lottery 3, but there's no winner yet. We want to just skip that one. So winner ID and continue, because there's a chance lottery number 4 has a winner. So lottery 1, 2, not 3, 4 has a winner, right? So we're going to continue, skip this one, go to lottery number 4. That's the way to look at it. So continue. And then after we do that, we can get the ticket address, right, because we want to know the winning ticket. and set that equal to await get ticket address, pass in the lottery address and the winning ID. This is how we get the winning ticket. The winning ticket address, and to get the winning ticket, you need to pass in that address. So program.account.ticket.fetch ticket address. Cool. So after you do all of that, you want to do a history.push, and then you can push the object. And what does the object look like? We can generate it similar to this: ID, winner ID, address, boom. So we say lottery ID is going to be the same as the ID that we're iterating on right now. It's going to have the winning ticket ID and the winner address, right? So this is where you see the 111. We can get the public key by saying ticket.authority, and then we can say the prize and say get total prize, in case you wanted to know how much was the prize of that lottery, like what it was. Okay, cool. Yeah, and so after all that's said and done, right here we can say set lottery to, set lottery history to history. Okay, so set lottery history is going to hold an array, right? So this is a state we haven't made just yet. Let's go ahead and hit save. Let's make that state. Say const lottery history, and say set lottery history is equal to use state, and we can say empty array. It should be an empty array here, and there's some things we want to do with this. All right, but the first thing I want to do is after get pot, let's also get history, so it's not grayed out anymore. And the second thing we need to do is pass in that array. All right, so right here we can say lottery history. Cool. And what we want to do with that lottery history is bring it here. All right, because how do we get the recent winner? Well, after we have the lottery history, right, you're going to get the last item in the array by doing lottery history to length -1. Get the winner address. We're going to shorten it with our function so it doesn't look like super long. And let's bring it out here. Lottery history. Take this out. And guess what? We don't have any more static data. So we hit save. And now let's finally test our function. Right? So when recent winner is 0. Right, that's interesting. Okay, so we will pick a winner. Oh yeah, we forgot to plug it in. We need to get pick winner here. Pick winner. Take out the static function. Save. Pick winner. Okay. Ooh. Usually there's something here. Let's hit approve, see what happens. Hey, we picked the winner. All right, so Kazi didn't win. I won all that money. So the pot's 10. That means, sorry, I was saying that means I win the 10 soul, which is amazing and cool. The recent winner is correct. It should be, yeah, me, right? So again, how much soul am I gonna end up with after I claim it? I'm gonna end up with 23 soul. Isn't that insane? So there we go. And the same thing that you notice is that I can't enter a ticket, and I also can't pick a winner again because there already is a winner. So the only thing I do is create another lottery, right? Another thing we can do is set up a can claim, right? We should be able to claim our prize, which should be set up already. Let's console log our can claim. Oh, can claim right here. So instead of connected, let's put can claim and put claim status. So if I'm guessing, it should be false right now. Oh, it's null. Okay, that's not good. Let's go to our context and let's figure this out. So can claim. There's a lottery. Lottery claimed. User winning ID. Okay, so it's null. And at some point it was false. Okay, so what we could do here is literally check all of these things. So user winning ID. Yeah, so it should never be false. We can check here. Console.log. There is a user win. Oh, this should be a string. See where we go wrong. Oh, we disconnected. Whoops. Okay, so that if statement isn't running. So there must be something wrong in this update state. Did we update state with the pick winner? We did. Okay, let's check our backend on the lottery. Fetch all. Oh yeah, winning ID is 1. Okay. So what did we set winning ID? Lottery.winner ID. Okay, so I think it's something with this user win here. User win. Okay, let's check if there's a user win. Right, this should have tests. Alright, so if you see this weird sentence, there should be something. False. What? But there should be tickets here. Like there should be something. Okay, well, what about user tickets? Alright, there should be 2 user tickets. User tickets. Tickets. Okay, show me the tickets. Empty. What? Alright, but if we go to the playground, there's 2 tickets. Alright. I have a theory that it's this filter. So let's take out that filter and let's just get it as is. Alright, yeah, there's 2 tickets. So let's hit phantom and now we can claim the prize. Oh my god. Okay, so I forget, do we need this filter? Alright, I think there's a reason why we have this filter, but for now, like I said, we'll just do an all here and we'll probably notice when it becomes a problem, right? But right now, the way I'm doing this filter is wrong, so I just removed it. We're just gonna do a .all to just get all the tickets. And now we should be able to claim the prize, right? And again, this is not gonna work because we need to make that function. But other than that, we set it up so we have that. And there's also this right here. I wanna see that as well. So let's see how I do that. POC card. Oh, it's actually the table, no? Let's go to the table. Table. Ah, yes, we have to bring lottery history here too. So we can say const lottery history is equal to use app context. Erase this guy. See what we get. Hey, look at that. So we also have our lottery history here. And now let's claim prize and we should be done. Okay. So yes, claim prize. Yep. So to claim prize, we need to go to the context. Alrighty, so we are in the context now, and what we want to do is claim prize, right? So let's reap our rewards. Let's brag it in front of Kazi's face that we got the 10 sol. Right, so we can say down here, const claim prize equal to async arrow, and we could say try catch. Right, at this point, this should be straightforward. We can say toast dot error is error dot message, and we can then say const tx hash is equal to await program dot methods. And what method would you like to call? I'd like to call it the claim prize one. Thank you. And what do we need to pass in? We need to pass in lottery ID and the user winning ID, which we set up. All right, so where do we set user winning ID again? User winning ID. Right here, set winning ID to that. Cool. Awesome. All right, so back to claim prize. All right, we're gonna pass in the winning ID, which was ticket number 1, which was me. Do dot accounts. Pass in the context, which and all the accounts that we need is lottery. We have that saved in lottery address. We need the ticket. This one we want to get because we want to get a specific ticket, and to do that we can say await get ticket address, pass in lottery address, pass in the winning ID, user winning ID, comma. We want to do our authority, which is simple, wallet.public key, system program, and say system program dot program ID. And there you go. .rpc here. Await confirm the transaction. Pass in tx hash and the connection. And we want to update the state, of course. Update state. And we can say toast.success. Here, claiming the prize. Or claimed the prize, instead of say claiming. Claimed. Okay. Cool. Claim prize by ticket. Yeah, I think we did all of it. So we can say claim prize. Let me just take one look at our update state. Is there anything else we need to do after setting the winning ID? No, after that, I think that's pretty much it. So yeah, it feels kind of weird that we made it this far, guys, but I'm really happy. This is a really cool app. So let's bring claim prize from our context, claim prize, right? Remove our final static function. All right, remove all these comments. We can even get rid of this console log claim here. Save. Let's go back to our app. Select winner, claim prize, and again, if I go to Kazi's wallet, should he be able to claim the 10 Solana? Let's go here. Right, he shouldn't be able to. All right, because he shouldn't be able to claim the prize. Yeah, the can claim should be false. Just to check, I'm going to bring back that can claim. I think it's true, actually. Claims can claim. Oh, because can claim is 1. That should be something else. All right, I'm gonna look in context real quick. Can claim should be true or false. Why isn't it true or false? Did I do this wrong? Come on, this is a home stretch. Claim. Okay, let's try this again. I'm gonna select wallet and I should see claim prize. There you go. Okay, so we can claim the prize. Let's click this. All right, and again, we should get 10 Sol. If I try to claim the prize as Kazi, we should run into that error that says, hey, invalid, where is it? Yeah, winner. Yeah, the last lottery ticket ID doesn't match. And already claimed. Oh, here we go. Invalid winner. All right, so if we try to claim it as Kazi, we should get an error that says invalid winner. But since I am the winner, right, I get plus 10 Sol. So from here, we claim the prize, we get 23 Sol. There we go. We finished the app. And again, if you wanted to make a lottery, you can. All right, create a lottery. Boom. Lottery created. We're good to go. So I hope you enjoyed this. This is an amazing app, right? We took everything we learned up to this point and we can make something cool like this. So if you liked the video, drop a like down below, leave a comment, tell me that this was awesome, and I'll see you guys in the next video. Peace.